It looks like we're live. Hello, everybody. Welcome back to yet another Hangout. Today, both me and my guests are going to talk about somebody that we haven't talked about in quite some time, namely Anthony Riley. With me today, I have Rumpus. Rumpus.
Hello, sorry, yes.
Hey, how are you?
Yeah, I'm well. I'm very well, thank you. And by the way, Alex, got to thank you for helping me out yesterday with all that modding and helping me out while I was panicking over some things. So thanks for that.
Sure thing, sure thing. Team Skeptic.
Hey, how's it going, Mr. German beer drinker guy? How you doing?
Pretty good, thanks. Sean.
Hey, that's a me.
Yeah, that's a you. And finally, last but not least, the great Red's Rhetoric.
What an intro. I love it. Let's do this shit.
Ooh, okay. So, as the more cautious audience among you might have seen, I've posted the link for Anthony Riley's video. It will be yet again about density and buoyancy. Yuck. So we're going to take a look at that and then debunk the mistakes that he's making. So let me share myself. There we go. I hope you guys are able to see it.
Yep.
Okay. By the way, it's called Flat Earth Giannora Relative Density. Let's go.
This is a video for Nora. She recently had a hangout with Travis, talking about gravity, density buoyancy, the rejection of density buoyancy, the inadequacies of density buoyancy, the misrepresentations of density buoyancy, the parroting of density buoyancy, and she made some statements. And I'm basically, I'm going to demonstrate how wrong this girl is, and why she's mistaken, and how she's basically dishonestly misrepresenting the position that's counter to her position. Nora's position is that there is some kind of universal up and down, and she cannot see how it can be anything other than up or down. She makes numerous assertions, and I'm going to present to you 3 assertions and basically pull them apart with explanations. And obviously my favorite picture of all time will be demonstrated periodically throughout, because it explains everything that we see, and you do not need any more. So without further ado, here would be exhibit 1 of 3.
I don't understand why people say density and buoyancy as if it's an explanation when it's not. It's not.
Okay, first off, you are quite right. Density and buoyancy on its own does not explain everything. Not many people that I know explains this using that phraseology. It appears to me, Nora, that you are misrepresenting the position. Nobody calls it density buoyancy when we're explaining everything that we see. It's described as relative density. On screen, we have all these different fluids, a couple of solids in the middle, and there is an alignment. Density and buoyancy alone doesn't explain it. You are correct. I agree. However, put the word relative in front of the word density, and then you are left with what you're looking at on screen right now. I've heard you say that why is it always up and down? Well, these are all immiscible fluids. All of the things that you see here, the liquids, they're all immiscible. And that just means that they will separate. They will not mix. When they separate, by virtue of that fact, you perceive an up and a down direction. What's actually happening is that these objects will not mix, and by virtue of that fact, they have to repel like magnets. They can't mix. If they were miscible, you would not say that there was an up or down. So we can contrast miscible fluids like Robinson's cordial orange, and you mix it with water, it mixes. So you wouldn't say that there's a universal up and down there, would you? No, you would not, because there's no evidence of a up and down direction, is there? But when they're immiscible, then you can see what you perceive to be a direction. But it isn't a direction, Nora. They can't mix together. They must separate. They're immiscible.
Can we stop for a second?
Okay. What do you got, Sean?
Okay, Riley, this is really, really, really freaking simple. As far as your density tower there goes, and that's what it is called, is a density tower. It's actually showing that there is a force pulling the denser objects down, and you can actually test this. Create your little density tower with the same fluids there, Riley, but at the very top, make sure you attach. You either have to drill a couple holes at the top of it on either side so you can put a string through it, or mount it some way that you can actually spin it like a centrifuge, and then see what happens to the direction of the alignment as it swings around you. It will more and more become a horizontal orientation because of a force that's not down being applied.
The one experiment that I always like to use as an analogy for this is, I'm sure you might be familiar with it, is the helium balloon in a car. What happens when you accelerate/brake in a car with a helium balloon attached in such a way that it can move more or less freely inside the vehicle?
When you push on the gas, the balloon will move forward because the denser air is being pushed to the back, and vice versa. When you hit the brakes, the balloon's going to go towards the back because the denser air is coming towards the front of the car.
Exactly. Usually when the system, meaning the car, is not accelerated whatsoever, the density and therefore also the pressure inside the vehicle will be identical everywhere in a horizontal direction. However, when you accelerate, as Sean said, the pressure on the back of the car will be higher, which the helium balloon feels as well. It's also pushed to the back. However, since the density of the air is actually higher than the density of the helium balloon, which is why it's floating, it's actually accelerated forward. And the opposite is the case when it's braking.
Yeah, this is the example of Newton's third law of motion. As you begin to accelerate forward, you create an accelerating force in the opposite and equal direction. You can then draw out a vector using gravity in one direction going straight down and the accelerating force in the other direction to get your actual your force vector, because it's going to be at an angle or whatever. It's not going to be straight back as long as you have gravity pulling straight down. There's always going to be some kind of downward pull no matter how fast you go. But this is it's actually that's what defines that force that the density tower would align to.
Yes, the next point is obviously that what happens when you do this in a vacuum, right? Riley said that the relative density, meaning the ratio of two densities of two different media, would be relevant. So what happens if one density is 0 because there's nothing there? Would the acceleration become infinite, or would it become 0? What would happen?
Yeah, that's a very good point, actually, whether or not the relative density is a percentage, a rate, a scale factor, or just simply a difference in additional, in subtractive, the difference between the two.
I mean, obviously, when you do the experiment, what you see is that all objects will see the same rate of acceleration, namely 9.81 meters per square second.
Yeah, and of course, the crucial test of all this, what his bollocks is talking is, could you please give us a formula for this? Could you tell us what force? Well, of course, he denies force actually in this. Of course, what we'd like is some sort of formula to predict what the force or how much something would weigh if we put a little string, a little weighing, a stretchy or whatever you call those weighing things you can hang on, pulling.
I think it's how is it called?
It's just a spring balance or something. Yeah, where you hang on to one end.
Spring with a scale.
In fact, I've actually got a pic.
It shows you how much force you need to pull, or how much force is pulling on that string.
Yeah, and in fact, I've got a little diagram of this. Actually, I can show.
By the way, we're joined by Hillel Finder and who is this other guy? It's Neslik. Hi, Neslik.
Hello.
Yeah. So here's an example. Yeah. So here's in a situation you can measure.
Wait, let me share your screen.
See my screen. Okay. Thanks.
There we go.
Yeah. So here's a situation here where I've got a submerged object displacing this amount of water on the right. Here's the object, and there's a buoyancy force associated with that, and of course a gravitational force. Now, of course, Riley keeps on claiming that the gravitational force, there is no gravitational force. It disappears when you put it in the water because there's no force.
Obviously, the buoyancy force is the difference between the gravitational force of that object and the gravitational force of the water that the object is displacing.
Well, no, the buoyancy force is just simply the displaced. The buoyancy force is simply the force of.
Yeah, so sorry, I'm talking about the net force.
Yeah, so okay, the net force indeed. The net force is the difference between the buoyancy force and the gravitational force. And of course, you can weigh it with a little spring meter like this, put something around it. And I would love, if Riley thinks he understands this, would he please like to give us a formula and then go and take an egg or something and then put it in the water and then tell us how much he thinks it would weigh in water? Of course, he won't be able to do any of that. But anyway, you carry on. This is that's off my little bit finished.
All right, Hiller/Red/Neslick, do you have anything to add to that particular point that Riley made?
Oh, I just joined, so I don't have a comment on it.
I mean, do you want me to go? I mean, I could go on a little bit more on this, Alex, if you want me to. Just how it's a diagram. Did you want me?
Yeah, I would like to touch on this too because I one time asked Southern Israelite in the Hangout why does ice semi-submerge at the surface of water? Why does it not just sit on top of water? Because if there's no force pulling downward, then there should be nothing like the ice should just sit right on top. Even icebergs, everything of different densities. If there's nothing to provide a force to pull down and to balance out with that buoyant force, why is the ice even sinking? What's their explanation for that?
Yeah. Yeah, that's a good one. So do you want me to sort of count a little bit, Alex? So there's Archimedes' principle, which is what we're just describing there. The displaced water here has a mass and also therefore has a weight. Remember, weight is a force, mass is not a force. Weight is the attraction to the center of the Earth, and that's given by mass times the little g. And the buoyancy force is the opposite of the weight of the volume of the water displaced going upwards, and obviously the mass, the weight of the object here, which if this is lead or something, it would just simply be mg, and then the net force is just the balancing those two. And of course, in a neutral buoyancy case, when this is the same density as that, I mean, I could go through the formula, but yeah, I don't want to take over this. Then obviously, when those, as we're saying, when those two forces are equal, then you have neutral buoyancy, and this force meter would then show nothing. Yeah, I don't want to take over this.
Here's an idea for an experiment there, Rumpus, because he says that, a neutrally buoyant object is no longer affected by gravity.
Yeah.
How about getting a clear plastic egg and filling it up with enough water to become neutrally buoyant when it has a nut or a bolt weight inside of it, and then wait for it to reach its neutral buoyancy and then turn the egg and watch what happens to that bolt inside of it.
Turn the egg. Oh,
yeah, just rotate it so the bottom becomes the top, and see what happens to the bolt inside of it to see if gravity is neutralized by a submerging of a neutrally buoyant object in water.
Yeah. So that's the key thing here. He believes that the gravity. Well, of course, he doesn't believe in gravity. Is half the problem. I mean, we've built lots and lots of problems here. We could go on with this for hours. I suspect he denies gravity. And then part of that is that he claims that one of the reasons he believes there's no such a thing as gravity is that when you have a neutral case, then there's no forces on it. And of course, he doesn't even understand what a force is. I mean, part of that video, I shouldn't really go on about the future bit, but yes, so because he denies gravity, he then, I've lost my point now, but yeah, the lack of gravity, therefore he believes that gravity disappears. So yes, I think that's an absolutely great point, Sean. That
to demonstrate that gravity is still active. Yourself?
Sorry?
Did you just rumpus yourself?
I did, yeah. Sorry. Yes,
Wait,
I'm agreeing with you. It's great.
As a verb now?
It's great. Just rumpused himself. It's poking a joke at the audience.
That's very good, Sean. Yes. So yes, I'm agreeing with you. It's great indeed to contradict, to make sure. A really big point is for him to understand that gravity isn't disappearing. So yes, I think that's a very important point to show. Yeah.
Okay, shall we continue?
Yeah.
Okay, so let me share my second screen again. Oh, Red's just left. He said earlier that he needed to go.
Yeah, so, he's got the yob thing to do.
Yeah. Should be running now, I think.
The order is caused by the density. We know that because we can manipulate it. And remember, all of these liquids are all in the medium of air.
Wait, stop. Before we continue, there's actually something I forgot to add. Namely, the fact that those liquids are miscible, and I think it's pronounced miscible, not miscible. Please correct me if I'm wrong about that.
No, you're right. Miscible. Yeah.
Miscible.
He gets it right, actually. He gets it right there. He gets corrected in a second, and then...
Okay, yeah, whatever. Doesn't make difference. Because when you have, for example, as you showed yesterday, a sugar solution, which, well, obviously contains dissolved sugar molecules, you will still get the density gradient. Because the sugar molecules, being heavier than the water molecules around them, will be pulled to the bottom of the container more than the surrounding water, which is why you get the density gradient.
Yes, though of course, let's not forget things like fluid. Because it behaves like a fluid in that case, it doesn't mean to say that all the sugar is going to go to the bottom. You know, that Boltzmann distribution.
No, obviously it won't.
Well, okay. Do you want to explain why it's obvious?
Yeah, the reason is that first of all, the actual different molecules would actually still be moving inside the water solution, even if there's no current, no obvious current in the solution. At any given temperature, the individual molecules still have kinetic energy.
Yes, and the point is that kinetic energy varies. So just like the atmosphere we have, all the carbon dioxide doesn't sit at the bottom. We have a large amount of mixing, even though the actual molecules that make up the atmosphere are different in atomic mass and density. But because of the Boltzmann distribution of the energies, as you said, the kinetic energy, that means they're effectively behaving if you have a very active oxygen molecule that's bashing around like crazy with lots of kinetic energy for one reason or another, because there is this distribution in energies, that means it will effectively be demanding more space. It'll become effectively, I'm going to abuse the term here, but less dense, because it requires more space to live in. If it's has greater kinetic energy, i.e. hotter, the temperature is a statistical phenomenon. You can't really call a molecule hot or not. You have to have lots of molecules. But if we more energetic, which is a result normally being a higher temperature, that means that you had an energetic oxygen molecule, it would then rise up, and the carbon dioxide molecule. Let's do carbon dioxide. That's the densest one in the air. Well, I suppose it's argon and xenon, isn't it? Okay, well, let's go with carbon dioxide anyway. If you have a very energetic carbon dioxide molecule which has been hit for some reason, or is very hot for some reason, it would actually rise up and not be at the bottom. And similarly, is it nitrogen? Nitrogen is the least dense one. Could go at the bottom because it might be a cold one. So the same sugar. Sorry, I had punchline. So that's why the sugar solution you'll get. Inclined to be more dense.
I actually slightly have to correct you. Nitrogen is not the lightest gas that we have in our atmosphere. We have traces of neon and helium, and also hydrogen.
Yes, sorry.
All those three are a little.
Yeah, the ones that live. Yeah, I call that. Yeah, that escapes. The one because obviously helium and hydrogen. Oh no, actually no, helium doesn't. Yes, helium does escape.
Helium does escape. Yes.
Yeah, that's right. Eventually, it will do that. So I was referring to the ones that don't have the escape velocity to get out. So the ones that it's the lightest one that will actually stable in the atmosphere. So yeah, you're right that helium and hydrogen, obviously, if they get into the atmosphere, it will be lighter. But that's not.
Yeah, don't forget that neon is light as well. That's because nitrogen and oxygen will actually be in the atmosphere as two atomic gases, while neon is a noble gas, so it's only one atom.
That's a good point, actually. Yes, good point. Good point. Yes, very good point.
So according to the ideal gas law, for example, you have to be talking about the individual molecules, not the individual atoms.
Correct. Yeah, absolutely right. Yeah. Good point, Alex.
Okay, so anything else said, or shall we continue? Sean, do you have anything to add?
No, I'm good for now.
Eslik?
I do have something, but it's off topic of the buoyancy, but it does have to do with the equation he used over here at neutral buoyancy. You said G will be 0 in free fall. Is that not?
Oh right, my diagram. Yeah, my diagram. You're talking about a diagram. Yeah, yes. If you represent me, I can show you that. Yes, if you want. Do you want to
well, what I was going to ask is that G like the
little g?
Little g that's actually felt, or is that little g in particular? Because wouldn't little g still be represented, except for when it's in free fall? Of course, it has the opposite force, like I was saying earlier, that would cancel the g out. Now G would appear to be 0, but wouldn't small g still be there though?
So so we talk about the neutral buoyancy condition here, and this is the formula for neutral buoyancy, which is that's the full formula. If any one of those three variables, so this is the net force. So here's the net force up here on an object in a medium. So it's just as Alex said, the net force is just simply the what I've called FO for the object's weight. I can't remember why I didn't go. And the net and the force of buoyancy. Remember, these are forces, not masses. So that's the net force will be the difference between the two. And then if you just do the calculations on what, because they're the same volume, because you've got the situation where the volumes are the same. Effectively, it turns into this formula here, where the condition of 0, where the two are the same, which is when this force is the up. I've just replaced the volume and density with the forces, because we know the gravitational deflation and the volumes cancel out, and you end up with this formula here for the net force being, this is the net force on an object being suspended in a medium, i.e. the buoyant case, and that will be 0. If the net force is 0, then that formula there is 0. So here's the neutral buoyancy case here. Now, if any one of those three things are 0, then there is neutral buoyancy. Now, obviously, the volume, if it goes to 0, that means there'll be neutral buoyancy. But when I say G here, it's the relative G. So yes.
Now I understand.
You're making a slight mistake there. Obviously, when the term rho O minus rho W.
Yeah, that's rho water. And
yes, the density of the object minus the density of the water, and that is 0, meaning that when they have the same density, then your entire net force becomes 0. That does not mean that the acceleration gets 0.
No. He was saying when one or the other.
Yeah. So if any one of those variables, if that sum there becomes 0, this equation will be 0. If that is 0, this equation becomes 0. And if that becomes 0, this equation becomes 0.
That was my question. Was when you say little g here, are you talking about the actual force or the force felt, like the relative force? And you answered the question.
Yeah.
Because even if G0, even if rho 0 minus rho water was, let's say, 5, if in free fall you would get a 0 little g, a 0 relative little g, and nothing would. There would be no force to organize the buoyancy.
Yeah, because you're in an accelerating reference frame, and therefore
right.
But only if you say in the accelerated reference frame, when you take a look at it from the outside, G cannot become 0.
Correct.
Yeah, which is why I wouldn't formulate it the way you did, Rumpus.
Yeah, I must admit, you're right. I think you're absolutely right.
That's why I asked the question, because I felt like it was formulated wrong.
Yeah, it's not quite as clean as I would like, because the
what I would do in your case is just take the entire equation that you have on a neutral buoyancy, add equals Fn, and then divide everything by the mass of the object. That way you become a acceleration. You get an acceleration, which then can become 0.
Well, this G, of course, is relative to the reference frame you're in. So I suppose what I could call that is G relative to the reference frame. And if the reference frame you're in is also accelerating, then this becomes 0. So yes, it's an absolute. So you've got it. So teams are completely. I mean, it's a good point. I'm not making it clear here that in free fall these forces and things are, this G is relative to the reference frame you're in, so it's a sort of relative G. So if you have a moving reference frame, accelerating reference frame, then this becomes 0. But yes, and you're absolutely right, Alex, that obviously looking externally, that G hasn't disappeared. But if you're looking from the point of view of the reference frame that's accelerating, G does become 0.
Yeah,
which is the correct way to look at it.
It looks a little bit like you're changing the reference frame while in the middle of the equation.
I wanted to include it because it seems quite fun to think, suddenly, hold on, if you do have an accelerate in free fall, you've got to account for the fact that the neutral buoyant, everything becomes neutrally buoyant, no matter what the density. If we've seen this video of a tower, density tower, and in that Vomit Comet aeroplane that dives, all the stuff just mixes up. Because it's all in that accelerating reference frame.
Which is why an accelerometer reads 0 in free fall.
Exactly, yes. And so this G, it's not the absolute. Yeah, so it's G relative to the reference frame you're in, and if the reference frame you're in is a Vomit Comet, then this actual G becomes 0. But yes, you're absolutely right, Alex. It's still G outside, but in the reference frame of the aeroplane, it has become 0.
Just don't call it G. Just call it acceleration at any point.
Yes, I could call it.
Don't call it G. That just confuses everybody.
I mean, honestly, flat earthers aren't going to understand what we're talking about anyway. But for someone who does, it just would. It would, if there was a flat earther out there who had some kind of modicum of intelligence in the mathematical field, they'll look at that and go, "Oh, look, he's saying gravity doesn't exist in acceleration."
Yeah, I mean, you're right. I should be. I mean, this was big enough as it was, and I just thought if I just put in G is equal to 0, I could. It's already a big enough document, and I thought if I wanted to detail that with regard to the reference frame, this would never end. But I just thought it'd be fun for people to see. to account, this formula that I've put in here can account for what happens in the vomit comet. And I thought it was interesting to say that there's more than one condition for neutral buoyancy. It's not just the densities are the same. If you're in an accelerating reference frame, such as the vomit comet, also you have neutral buoyancy, whatever the density.
Let me ask you one more question then. Every time you reference little g, are you referencing it here as the same way that you're referencing it in the neutral buoyancy as far as in a reference frame?
Yes.
Then all you have to do is put a little star at the top above Archimedes' principle and make a note that g is in the relative reference frame.
Yes, and obviously for most cases,
acceleration inside the reference frame.
That's and obviously for most 99% of all cases, it is actually the reference frame is 0. Therefore, it's the correct g. But yes, it would So it's a good point, Steve. Yes, I just didn't want to go into that, and I was So, but Alex is right to say there's an issue here. It's not the So, but it's complicated. So and I didn't want to go on and on about it there.
Okay,
but it's actually proof of gravity. This is actually proof of gravity. This is more proof. The Cavendish experiment is proof of mass attraction. So that's different than proving the gravitational force of the Earth. We're actually proving the gravitational force of the Earth with these experiments in free fall and the experiment with the car driving forward and the helium balloon moving forward. All these are, these take into account a gravitational force pulling directly down. And if gravity is proven to be true, then the Earth cannot be flat, because we would notice this as we walked further away from the gravitational point.
Okay, let me quickly share Nestlek 20's screen, because he's actually sharing footage from the Vomit Comet, in which a container with 2 different liquids at different densities.
Three different liquids. So water and vegetable oil and some other liquid. I don't know specifically which.
You're not showing the screen, Alex.
Oh, wait. There we go.
I can do vegetable oil and FC72. I don't know what specific liquid it is, but
what, SC72?
Yeah,
sounds like a hydrofluorocarbon. Wait a second. SC72. No, I'm not finding anything.
I will show you at the point where it says this. Let's see, like this.
FC72. Okay, I thought SC.
Oh.
FC72.
Damn it, my Dutch accent.
Perfluorohexane.
Yeah.
Yeah, I thought you said SC as well.
Yeah, whatever. So that's C6F14. And obviously we're talking about N-hexane in this case.
Okay, you see the normal with just normal G, and at one point right now, I think now it started to get to 0G, and you see the liquid just.
They mix based on random motion at that point.
Yeah, at that point, yes.
And see, the thing is that if gravity didn't exist, the moment that the plane went into the free fall, you would have the aligning force would be straight up. So the actual, if let's just say it was they organized themselves naturally into the denser objects without any gravity, the moment that thing starts to fall, only 2 possibilities could happen. They remain organized in that, or the force pulling up would actually have the liquids flip and reverse in densities, and you would have the more denser objects at the top of the density tower.
Yes, which goes back to your helium thing. You mentioned the cars, the helium balloon that Sean mentioned and Alex mentioned, which is this is exactly the happening here, where you get, if you start accelerating it, you can imagine this is the 0 case, this is the no acceleration. Then, as you say, if you then
the only difference being that we're talking about vertical acceleration here instead of horizontal one.
Yeah.
Right,
but it's exactly right. So, Team Skeptic's point is exactly correct. If you manage to get it to the free fall situation, like it's there, then you can accelerate one more or the other, and you can make it go to the bottom or the top, just as you can with your car and the helium balloon. You can make it go, depending on which way you decide to accelerate. You can make it go. Get the density of the air then becomes important, accelerating one way or the other. And similarly with this, the densities would only become important when there's an acceleration. So the density doesn't matter when there's effectively a net. In this reference frame there is no acceleration. Immediately there becomes an acceleration, just like in the car situation. You then get these things sorting themselves in order of density.
Yeah, I believe it's called a fictitious force. Is that not correct?
Yeah.
All right. Apparently, Neslik, you have to leave as well.
Yes, sorry.
Yeah, I mean it's fine if you don't.
Oh,
have the time,
this is my. It was my
Yes.
most important. It's my most important point I have against this buoyancy argument. Like please explain the Vomit Comet observation.
Oh right.
Yeah.
Oh, so you didn't do that in response to my point. You just did that. Okay, you had to come along with that. Right. Okay.
Yeah. All right. Bye, guys.
Bye, Neslik.
Bye, and thanks for joining. Okay, so let's just continue with Riley's original video. Okay, let's see.
So even though these liquids have all got layers, and there seems to be a direction in your opinion, they're all in the relative medium of air. Just remember that, because it's relative. The bit that you always forget to mention when you're countering with density and buoyancy doesn't explain everything. The bit that you're missing, Nora, is that they're always in air. Or
Yeah, I was about to say.
Yeah.
Let's just do a little thought experiment here and exchange the atmosphere surrounding it with the vacuum. Obviously, under the condition that our liquids that we have here don't boil off.
Well,
Yeah, you could just put a top on it, of course. You could just seal the damn thing.
That's exactly what I was thinking. Would it change it if we sealed it and had no atmosphere in there at all?
Well, that's the thing. The only thing that's being affected by an atmosphere at all is the lamp oil in his favorite picture. Everything else has nothing to do with the atmosphere.
Yeah.
Yeah.
Nothing. So
Anything
don't need
else?
a lid. The lid is the lamp oil.
Yes, very good. Yes, that is effectively the lid. Yes, if it didn't evaporate, then it would be. Yes, it is acting as a lid now, and providing it remained intact in a vacuum, it would continue to act as a lid.
Yeah, that's the other thing they don't get, is that containers are nothing more than being held together by forces. Okay, these forces can be broken if you add enough. Let's say you add enough liquid in there. You have a plastic top container. You can create a vacuum, or you can create a seal with that. Sure, but it only has so much force holding it together because it's made of plastic. You exceed the force on the inside of the container, and it will blow out the top. The same way that the plastic top is a something on top, so is the air. It's no different. It's the exact same thing.
So I think it's a good way of describing it there, Sean. I think it's the lamp oil is a lid.
Okay, anything else said? Nobody? Okay, let's continue.
another medium, and it's relative to that medium. Always. Every single scenario that you can ever mention is always going to be relative density.
There we go.
Stop misrepresenting.
I think that might be the quote I was looking for. I think it was either that point there, or it might be a few seconds later, where he says everything can be explained by relative density. And I was then going to chip in with this other diagram that I've got.
While you're doing that, I'm going to do something quick that will illustrate my question.
So,
let me share your screen.
Oh, I'm not quite ready yet. I'll let you know.
Okay, well, I'm ready.
Okay.
So here, I think it's here. I think that was the point I was looking for. It might be it says it again, where it says everything can be explained. The only thing you need to know is the relative density of the two things. So here I was saying, okay, then I was going to propose this experiment. Here we have, I've got this fluid held in a membrane. I'm going to make it vanish in a moment. And I've got this medium 1 and this medium 2 of density A and density B. And let's suppose I make density B, I don't know, let's make density B greater than A. So density B is greater than A. So perhaps Anthony would then like to tell me what will happen next in this diagram. What's going to happen? So this density in the medium here is greater than A. What would the only information apparently he needs to know is the relative density. He's saying everything can be explained. Possibly is the quote in a few seconds. He says everything can be explained if you know the relative density. Everything else comes through the wash. You can predict everything Everything can be modeled just with the knowledge of nothing more. The only piece of information you need is the relative density. So here I've got a situation then, Anthony. I've got an object, a one medium here that I've got in a membrane. I'm about to remove the membranes around them, and off they go. What's going to happen? And of course, he's going to say, oh, the density, because this density, this one B, is greater than A. Obviously, it's going to fall down to the bottom. Yeah, but unfortunately, the Earth is here. It's going to go to the right. Oh, that means you must need more information about what's going on. Oh dear, the relative density isn't going to be enough.
The interesting thing is, what does he think is going to happen when there's nothing else around this thing anyway?
That's a good point. Yes.
Well, and that's where I was going with what I'm showing here is that when you are looking at a single object, a single fluid, a single gas, a single whatever.
I'm screen sharing you now, Jared. There we go.
Where the fuck does relativity to anything else come into play in this equation for density?
Absolutely. Just a little bit triggered that you used the capitalized M for mass.
I did that so it was easier to see for the people.
Okay. You know, and hey, Rumpus, another thing about your picture. What if there was a density that was denser than the blue denser than the inside density, but not, you know what I'm saying, on the outside? Would the blue move out, or would the darker one move in?
Yeah,
I mean they don't have any explanation for any. Like, you can always just throw one more variable in, and it's going to fuck everything. Their head will explode.
I mean, but also no predictions for anything. That's the problem.
Indeed, Jared. I mean, Jared's made. Actually, I didn't include that. I meant to make that point that Jared made. Absolutely, that equation which gives you density. There's no direction. It's not a vector. There's nothing in that equation for density, which is as he's described, just simply mass divided. There's no direction in that. There's no direction. It has no direction. There's nothing in that equation that tells you where it's pointing. Sorry, okay. And so therefore, without there is no direction with relative density. You fundamentally do not have any direction information. So therefore, you cannot account for the fact that it's going in a particular direction. As I'm saying, if I was to ask that question of Anthony Riley, without that Earth there, he wouldn't know what to do with it. He could not predict what was going to happen. And as skeptics said, you know, if you put something around it, well, okay, what you don't have directions. There's nothing directional, so you can't say what's going to happen without some information about what direction the denser stuff he wants to go to relative to, and you only can do that if you know where the Earth is or something.
I think something that's also very telling is that if you change that direction, which is quite possible to do, as I believe Sean pointed out earlier with, say, a centrifuge, then the relative densities will order themselves in a direction that is not the same as it would be if it were not in a centrifuge. For example, if it was a horizontal centrifuge, then they would arrange themselves such that the densest was the furthest out from the center. In a way that is, in a way
and that goes back to the helium
on the ground.
And that goes back
it's not just that there is a direction and it picks an arbitrary, apparently picks an arbitrary direction for them to be relative to each other, but that you can easily change it by accelerating the fluid, by accelerating the
a density tower is going to align itself in the direction perpendicular to the net force.
Yes, exactly. That's the fundamental thing they don't understand. They don't understand that for any movement to happen at all, you require force. For any ordering of the different densities, you require a force that is applied from the outside.
And this goes back to the car thing that Sean and you mentioned at the very start here as an idea, because there you've got some acceleration which behaves like a force, and without a force in the system, just like with the vomit comet, immediately you eliminate forces, then you do not get any partitioning. There's no stratification without a force being present, either whether that's gravity or the result of acceleration in a car.
Exactly. That's why I said to do the experiment on the string and just swing it around and see how it all lines up.
Great, and that's another example. Your centrifuge example was another fantastic example there, where you're subjecting the system to a force, and therefore the density will go in the density will go in that along that line of force and displace the less dense stuff, because there's a greater force acting on it. Immediately you get a force acting on. If you have a force acting on a thing that's denser, you've got bigger force on it than the smaller force acting on the less dense stuff. The stuff with the greater force will displace the stuff with the less force on it, whether that's in a centrifuge, in the car with the hit there in the balloon, or on the Earth.
Yeah, you can actually. I think you can use Pythagoras' theorem to predict what the net force will be, and in which direction the vector will be pulling, I believe.
So we can actually handle Anthony's entire video with one simple phrase. And I just lost my train of thought.
I got it.
Anthony
Riley, you're a fucking idiot.
He did his thing. He did it.
But
Okay,
no,
let's continue.
there's actually a thought. I'll think of it here in a second.
Yeah, I know where you're going, Sean. You just need to formulate the words.
Hey, can I interrupt to say that the Russian lady that I did the video on this morning, she commented already on my video and she called me a sodomite because I said that the CIA was trying to sterilize her.
Isn't that a compliment at this point?
So to get back to why we can destroy Anthony's video in just one phrase, without a force, you will never have a density gradient, ever.
Yep.
Yes.
Good description, Sean. Yep.
Okay, let's continue. You're only 1/3 through this video, by the way.
In the counter by missing the word relative off. So here we have a good example for Nora, for Nora. We have a container, we have some liquid mercury, and we have...
Go ahead and chug some, Anthony.
An anvil.
Chugging mercury isn't as dangerous as you think.
But we also know that mercury is pretty heavy too.
Ingesting large amounts of it, though?
But notice that they're both in the medium of air.
As soon as there's any
air has a density
enzyme or
value
whatever
of basically 1 gram per cubic centimeter.
You're fucked.
1. Whereas this mercury...
Did anybody notice this? Apparently no, because I was talking over it. Let's hear that last few seconds again. Let's see who notices the mistake.
Air has a density value of basically 1 gram per cubic centimeter.
Stop.
What? That was yeah. I've actually made that in the notes for this thing. He's talking about the air there.
Water, right?
He's off by a factor of 800. Air has a density of about 1.2 kilograms per cubic meter, which translates to 1.2 milligrams per cubic centimeter. Whereas water has a density of approximately 1 gram per cubic centimeter, and mercury has a density of 13.56 grams per cubic centimeter. Side note, I actually had to handle approximately 150 milliliters of mercury in the lab one day, and the stuff is really fucking dense and heavy. It's heavier than lead.
Yes, it is. It's 13. A lead is only, I think, 8, isn't it? So this is
11, I think.
Oh, 11. Okay, thanks.
But compared to gold, there's nothing. I actually handled a little bit of gold once, and the stuff is approximately twice the density of mercury. It's like 19 point something. Just wanted to put that out there.
Yes, you're right, actually. Yeah, gold is right. Gold is in density, yeah. Yes, and he gets his units confused as well. He later on claims that air is 1 kilogram per cubic meter. Oh, that's right. He says he compares the... Yeah, sorry, it's in the future, so we can wait till then, yeah.
Yeah, actually, I had a little bit of a conversation with him in the comments. We're going to take a look at that later once the video is done. So let's continue.
Meters cubed. 1. Whereas this mercury is 13.56 grams. So it's heavier than air, right? So if you know that the value of air is about 1, and you know the value of the mercury.
Right, so stop there. It's 1. It's not 1, of course. It's not 1 gram per cubic centimeter. It's 1 kilogram per cubic meter. So there,
yes, so it's 0.0012 grams per cubic centimeter.
Yeah, so he's out by 1,000 there. He's actually got to use the wrong units, and therefore he's out by 1,000.
Well,
is this kilometers and meters all over again?
Yes, it is. It is certainly.
It's not quite that bad.
All over again.
It's not quite that bad.
I would say it is.
It is really okay. Really. Well, he doesn't repeat. Well, yeah.
Okay.
Well, I think there's actually just one more thing there, which is that he said that mercury was denser than air, so therefore heavier, and which is just first of all,
saying heavier when he means denser.
Particular, or I suppose mainly all flat earthers' model of density. There's no way of, if you're looking at just density or just relative density, there's no way to say just through object's density which one is heavier than another.
Yeah,
say, if you have a little wooden block, and then you have an oak tree, and let's say they happen to have the same density, which if all the density is all that matters, which one is heavier?
There's two things. Obviously, they're forgetting. First of all, they're forgetting the mass itself, and they're also forgetting that this only applies when both objects are accelerated in the same way with the same acceleration.
And this comes out the classic case: what's heavier, 1 kilogram of air or 1 kilogram of lead?
I prefer the ton of feathers or 2,000 pounds of lead.
Actually, the ton of feathers is heavier because you have to carry around the weight of the psychological stress that you put on all those birds.
Oh, God. It's only 26 and a half thousand.
Right. Okay. So I just wanted to get in the fact that you got the units wrong when you stopped it there. So that was Alex.
Yeah. Wait a second. Okay, let's continue.
What the value is for steel. You're gonna have to do a conversion here because I got this in kilograms. But a quick online conversion brings it down to 8.5 grams per centimeter cubed. That gives you 3 relative values there. You can forget the units at the end. As long as the units are all the same, you can forget the units. All you need to know is what are the numbers.
Shit, he got something right.
Yeah, but he then gets it wrong but he's about to say, I think, that then the air around here is 1. So he gets it wrong.
You already did that. You already fucked that up.
Stop. I'd like to point out one thing here for you, Riley. If it was down to density alone, that anvil would never sink below the surface of the mercury.
Exactly.
Correct. That's exactly my point about the icebergs. They should never, if it's just density alone, there's no force pulling down, then the iceberg should literally just sit on top of the water.
Now, just to remind Anthony real quick, go back to your favorite picture, the density tower, and notice that the higher density items are not, or the lighter density items are not sinking into the heavier density item or the higher density items.
Yep.
You would have the same result with the anvil and the mercury. The mercury would float entirely on top of the surface of the mercury if it was density alone. Someday you might understand that.
Yeah, it's a very good point.
Wait, I just realized, how do they explain stuff like, I don't know, any modern ship or basically any ship that is made of metal which also floats?
Outside.
That was Sly.
Density.
Sly's here.
Density and perspective.
Yeah, it's the perspective of the audience.
Perspective.
I don't really know what I have to add next to a chemist in a chemistry discussion, but okay.
Well, currently this is basic physics. This has nothing to do with chemistry.
Oh, well, since you put the word basic in there, I guess I can be part of this.
Oh, God.
Yeah, and he's about to talk about forces, which I think is very important because, of course, as Jared showed, density is just density. There's no force involved in density. Density is just a description of the mass divided by the volume. There's no force involved. Now he's about to talk about forces. Where did they come from? Excuse me? But anyway, Karen, he's about to discuss that.
So I've got the numbers on screen. You've got the mercury at 13.56. You've got the anvil at 8.05, and obviously the air that both of the things sit in is just 1.
No, it's not 1.
No.
You can actually stop that.
No.
That's the one that.
Take a look at the screen that's being shared right now. That individual frame. Is it fair to say that about half of the anvil is submerged in the mercury and half of it is above the surface?
Approximately, yeah. Yeah. Almost like it would if you actually do the buoyancy calculation that you would for displacement, similar to what they do for designing ships.
Exactly. Let's just say that this this anvil weighs, let's say, 80 kilograms. Okay. That means that the mercury it displaces also weighs 80 kilograms. Now, since mercury has approximately double the density, let's just round this to 16, fuck it, 16 grams per cubic centimeter. That would mean that the volume of mercury that is displaced is half the volume of the mercury of the anvil, which is what we see.
Yep.
Just putting that out there.
Yeah, that's good. That's good.
And it's equal in weight.
Yeah.
Yes.
Items that are buoyant will displace their weight. Items that are
and
not buoyant will displace their volume.
Not to point out the obvious, but if they let go of that anvil without gravity, that motherfucker should just start fucking flying up in the air because the mercury would push it up and that would be the force and there would be no other force to stop it from going up anymore.
Pretty much. Well, actually, we would be kind of wrong there because because gravity would have to actually push down on the mercury to make it fly out in the first place.
Yeah.
I was just talking about the trying to level out and get the anvil on top of the actual mercury, since it's obvious the guy's pushing it down here. He's not actually, it's not gravity or anything like that. So if you let go of that, the mercury would try to get underneath the anvil, causing a force upward. I would
not if there's no gravity.
I'm trying to laugh at him right now.
Am I reading this correctly? You've been on here for about almost an hour, and you're only at 5 minutes and 36 seconds.
Yeah, approximately. But
there's a lot of material to get wrong here.
Have you ever seen Movie Night?
Yeah, no, I have. No,
it takes 4 hours to go through a 4-minute video.
Did you guys notice back at the 3-minute something mark that that he said that he can manipulate density?
I missed that.
No, I missed that.
He said he could manipulate relative density.
Right.
Yeah, that's not as wrong as the rest of what he's saying here.
Well, yeah, but no, he was saying that they can test this because they can manipulate it.
Yeah, I think what he meant was that you could choose different fluids with different densities.
Yeah, that's what he meant, I think. Yeah.
Well, it sure would have been nice if he would have said that.
Oh, he's stupid, though, isn't he? I mean, he's not gonna.
Let's just give him the benefit of the doubt and assume that he's not as retarded as he obviously is.
Yeah, because
spoiler alert, he's a walking contradiction.
I mean, all that missable stuff was completely irrelevant, as Alex pointed out earlier. And goes on about that at length. It's completely and utterly irrelevant to everything. I mean, where do you start with this guy? You could spend. He makes so many mistakes. You just got to pick on the 4 or 5 biggest ones he makes.
Yeah, the first 2-minute dialogue he had to open up this video, there was just nothing even right about it. I mean, it was not even close to right. I mean, how do you even argue with what he's saying without saying, dude, do you even know about science at all?
Which he doesn't, of course.
No,
he doesn't.
He is a failed lawyer.
Yeah. I'm just waiting to talk about force because, of course, he hasn't introduced subject forces until here. And then, of course, I say with that Jared equation, there's no mention of force in that equation. And suddenly, forces are popping out of nowhere. We need to know where they came from, Anthony.
They came from the beach.
Oh, God, Sean. Holy shit.
Oh,
it's such a shame that he's spending those, I don't know, what was it, 2,000 pounds something on a law course in university? While he could be spending it on either a physics course or just a basic level science course in general.
Or just
or actually getting his CPC.
Or paying for his fine.
Holy shit.
So here's my thing. If they really wanted to, that amount of money, right, that he could legitimately put it in to buying basic college level physics and science books that he could actually read, and the normal person can understand the context enough of some basic science. That's all he needs.
Well, here's what I would do if somebody spent me a couple of grand for some kind of an education in the effort of furthering a career to make money, of course. Now, I mean, we can't tell him which career to pick, of course, but I think it would be much more interesting because if he would apply that money to, if I actually believed in the Earth being flat and I felt that I could prove it, I would actually invest that money or invest money period into an experiment that would prove it. That would make my ass rich.
Oh yeah.
Well, but his goal.
I mean, you get what I'm saying?
He'll be world famous.
His goal is to get a flat Earth paper published.
But who's going to fucking read it?
Who's going to publish it?
Because the very first thing that's going to happen is somebody's going to say, okay, prove the claims that you make in this paper, and then he'll say that's a reversal of burden of proof fallacy, and then you'll get letters from Quantum Eraser who literally said to me 3 times yesterday that he doesn't have to prove anything by the scientific method. So what value would a paper have without any kind of backup to it?
Well, the thing is, he wouldn't obviously even get it published, right? Because the correction readers in the scientific journals that would publish it would immediately reject it.
Yeah.
Mm-hmm.
Yeah, but I suppose he's got to. Yeah, but as Sly said, if he could actually, if he really thought what he believed in was true, then obviously he should realise that's going to be a problem, and he's going to need to provide some evidence on his behalf or some sort of argument that's going to work.
Well, to clear up the straw man about the whole, he's trying to get a flat Earth paper published. He's not trying to publish a flat Earth paper. He's trying to put a paper forward academically, dealing with the education system being about repetition instead of actually teaching people how to figure things out.
Yeah, but he's got to claim there's a contention on the flat Earth situation. So he's yes, you're right. It's not on paper. He's got to show that that's a reasonable thing to have a contention about.
But he's not going to be bringing up flat Earth at all in this paper. His paper is literally saying that the education system is just repetition, but it's not teaching people how to get to the conclusions.
Yeah, but the problem with repetition as an arguing point, it's going to, a lot of things are going to be repetition in a simple education because of the fact that 2 + 2 is going to be 4
every time
for the next 50 billion years.
Every fucking time.
Yeah,
so there is going to be repetition in education.
Yeah, I mean, education is disseminating the body of human knowledge, and so you've got to contend. Therefore, if you don't want that to be repeated, you've got to contest the piece of human knowledge that's being disseminated by education. So you have to challenge that piece, and so he can't argue that everything is contentious. He's got to say, you've got to accept what's in the accepted body of knowledge, and then it's going to be taught. So you can't argue. It's not the educators that they take their lead from the educational material. So he's got to challenge whether or not the educational material is not the act of people disseminating what's in educational material.
Right, because the only thing in today's educational curriculum that could honestly be in any way, should I say, falsely repeated. In other words, stated lies and then repeated would be history. Okay, because and like what I mean by history is, we don't know that Eratosthenes did the experiment that we all call the Eratosthenes, right? And but every other bit of education, from metal shop to physics, is going to be repetitious.
Graham Matthews just corrected me, and I'm going to acknowledge the correction. He says Riley wants to prove the material presented within the education system cannot be proven.
And how is he going to prove something that can't be proven?
Exactly.
No, but see,
as Sly says, history would have to go out then, because you can't, unless you're going to use the sort of logical form of proof. In fact, nothing's provable. We can't even prove we're here. We can't even prove we're real. We're not a computer program. If you talk about logical proof, then nothing is provable except the fact that we've got memories and we have sensations and very little else, and that we've defined things like maths. And then you can use deductive logic to prove things. Having defined some basic rules, you can then prove other things from things that you've defined using deduction. But almost everything else about particularly anything to do with your senses that we've got, you cannot prove any of that. And this is, of course, why people tell him you cannot prove any of science, because all science is about working out how the natural and physical world works, but we can't prove that it's out there. So that's why we have to make assumptions. Exactly, you have to say.
Here's the thing, Rumpus. I don't think that he has yet used solipsistic arguments, but there seems to be a pattern, especially with religious people, that whenever they cannot defend their evidence, or when they are shown that the evidence is false, they will move goalposts and switch to solipsistic arguments, saying that reality itself could be faked and therefore no evidence whatsoever is valid.
Yeah, and the point is, what do you mean by proof? You've got to make sure whether or not you take the sort of scientific proof, because Nathan, for instance, would often say this has been proved, but he's sort of talking about, he confused that with logical proof and physical proof, and then says affirming the consequent, and how do you
prove, you muppet?
Sorry.
Yeah. So the concept of proving something is not that it's directing the evidence. It's letting the evidence lead you to a logical reasoning.
And this is inference.
Yes.
And so, in other words, it's something like, for instance, the sun. That comes up every single day over the horizon, but simply because it's done it every single time we know in history that's what it's done, or from as far back as we do have it on records, that doesn't mean to say that tomorrow it might not. Newton's laws, as far as we know, there's been no exception, but we can't know except obviously the Einsteinian correction, but there could be corrections to that. All we can make is inferences from inductive logic to say that this is what happens, and we don't know there's not an invisible green fairy doing this all the time. We don't know that invisible green fairies are not actually responsible for gravity. We cannot prove that. All we can say is it seems from induction that's what occurs, and that we will see the sun rise tomorrow, but we can't prove it logically. You can only do it by induction.
I have to apologize, Rumpus. I called you Muppet, but you channeled my inner Nathan. So,
yeah, I shouldn't really mention that word.
And this is done daily by people like GeoStriver here who are in a lab and don't just go into the lab blindly. They don't get taught one thing in class and then go over to the lab and do something completely different because the shit they were taught in class has no actual, useful application. And when someone gets to his point, he's relying on, for lack of a better word, the chemist giants of the past, the people who've made certain discoveries. And if we always had to go back and rediscover that same major discovery, we'd be stuck on discovery 1. So we build from that. We build from that education knowledge, that knowledge base, and we improve upon it. We do improve upon it. Nothing about science says that there's no room for improvement. There's always room for improvement, but it's improvement. It's not just changing it. It's improving it.
I think absolutely that's a really important point, Skeptic. We build on the existing human knowledge. So when, for instance, a person remain unnamed says people use the value of radius of R when they're doing something else, you don't. If you're not in the process of trying to prove the radius, you're trying to use what's obscured by the Earth's curve. You don't have to go through and prove radius. You just accept the values that have been proved by other people. You don't have to prove that 1 + 1 = 2 either in your calculations or your experiments.
And plus, when you use those calculations in an experiment and the experiment matches reality, guess what? You've proven those, or at least validated those numbers.
That's a really important point, Sly. Yeah, if you have a model and it makes predictions, and then those predictions are match and comport with reality, you can say, "Ha, this model is correct." And if you've got another model, like a flat Earth one that makes predictions that do not match reality, you can reject it. One thing you can do with science and maths is you can reject things. You can't prove things, but what you can do is, prove that things are not correct. That is something that science can do. You can say that this does not comport with reality, but you can't prove that the invisible green fairies are not pulling all the atoms towards the Earth. You can't prove that, but what you can prove is that not happening.
Hey, Rumpus, spoiler alert, Earth isn't flat.
and one of the reasons why flat earthers try to avoid presenting a model like the plague.
Yeah,
because
they used to present one all the time.
Yeah, exactly. But they apparently now they seem to avoiding it.
Well, that's because myself.
The reason is that whenever they seem to present anything, they apparently know that it's gonna be disproven.
Yeah.
It's gonna to be shown to be delivering unreliable results or wrong.
Well, here's
results.
the thing, Gio. They used to tout the AE map as their model for a year until people like Mirai Ziller, 5 Red Pairs, M. Goudsmith, myself, Cool Hard Logic, and Mortimer 81 all actually tested out the flat Earth model in various respects that they were presenting. And we showed that it doesn't work.
I did it too.
You did it too as well. But
you and Red's got a Sly phobia or some shit like that,
Sly phobia.
Sly produces the prettiest pictures.
Sly's our rendering bitch.
I love you, Sly.
I got you, bitch.
but we love you, Sly.
Yeah, one thing I have a problem with flat earthers is I truly believe that this is for the ones that aren't posed, for the people that truly believe in it. I believe they truly are suffering from some kind of mental condition, because a normal human being does not hold on to non-predictive models. We do not. Normal human beings logically hold on to predictive models, things that offer us predictive values in the future.
Well, in physical, yes, but in psychological, no.
Yeah, brings me to another point. This is directed towards Sly, since we love you so much. Remember what Riley said in your hangout the other day about?
Oh, now I'm here.
You directly, because remember what he said about his model is that he doesn't know what shape the Earth is, but he knows it's not a sphere.
Mm-hmm.
Today on Oakley's show, he actually said, "We know it's flat."
Okay, well,
but refuses to prove it.
He contradicts himself. Yeah.
Well, and Nathan said it 1,000 times that he says the Earth's flat, the Earth's flat, the Earth's flat, and all this. But
and then he says he's not making any claims. It's really funny. He keeps on saying the Earth's flat, the Earth's flat. Oh, we're not making any claims though.
At this point, I need to remind you of something, though. Remember the hangout we had? I think you were there, Sean, and you were there, Rumpus. I'm not sure about you, Sly. We had on Steve McRae's channel with Oakley, Riley, and Chris Moxley back then. Remember the definition that Riley gave for a flat earther?
Not off the top of my head.
He said that a flat earther is anybody who doubts that the Earth is spherical.
That's not even grammatically correct.
Yeah. I mean, because the default of not sphere is not flat.
Yeah,
it could be a donut.
What he was saying. He said that as soon as you don't think that the Earth is a sphere, you're a flat earther.
Yeah, because there was an argument initially in that hangout as to whether or not he was trying to disprove a spherical Earth or prove a flat Earth, and I think in the end they decided they were trying to disprove a spherical Earth.
That's been Riley's goal for a long time.
Yeah, I mean, he does occasionally say that we could be living on an Earth that's just very much bigger than the one that's been claimed. I think he's used that, but he doesn't.
Well, because leading up to the ultimate demise of his previous channel, he had a live hangout with me. Well, he was having a live hangout, and he invited me onto it, and I was walking the dog, and I kept on telling him, I was like, well, I will gladly take your bet, because he was making bets and predictions and all this other shit. I said, I'll gladly take your bet, and I'll even bet my channel if you show me what your counter evidence is. In other words, what's your model? What are you basing this presumption on? And he must have said probably about 50 times in that. He was like, I don't need to have a model to doubt the globe.
Which is correct. You don't have to have a model around to disprove something else. It's like if you want to disprove that 1 + 1 is equal to 2, you don't need to prove that 1 + 1 is equal to something else.
But you have to have information or evidence that would motivate you in that direction.
Well, you just need evidence that contradicts the. I mean, if you're doing some science, and if, for instance, if Alex found something that contradicted existing, you did an experiment that contradicted the existing orthodoxy, he doesn't have to prove that something else is the case. He just simply has to. You can simply prove that the orthodoxy is wrong. So you don't have to have a model of your own to disprove an existing model. But
if you claim that the Earth is flat, you need a model.
Oh yeah, if you claim the Earth is flat, yes, you do.
Yeah, physical.
But you can claim the Earth is not spherical without having a model.
Yeah, if you can disprove the sphericity of it, yes, but you don't. But that's only disproving somebody's model. That's not replacing the model.
Exactly. Yes, that's the point I'm making. You can. There's two situations. You can disprove an existing model, but you do not have to have a replacement model to disprove the validity of an existing model.
Right.
I think we need to continue at this point.
Oh God, you're only halfway through.
Yeah, I know. By the way, hello, Micro. Welcome.
Hey, it's the closed caption killer.
Oh, sorry, Slow. You were talking to QE today. Where was that? Was that in some just on comments or something?
No, he and Riley decided to come over and bombard my my comment sections on my last video. It was funny.
Ooh, I would like to see that later.
Okay, it's humorous reading. It really is.
Okay, let's continue this time.
But you can see that these numbers are all relative to each other. You can also see that when you apply a force, you can make one of the things move.
There you go.
You need force to make it move.
And there's a force that comes back at you, isn't there, Anthony?
Is that an anvil in Mercury?
Yeah.
Yes.
Yeah.
Guys, I can't hear anything when you're talking.
I just wanted. That's the first mention of the word force. You see, that's why I was looking for this. And then and that means whenever you apply a force to something and it remains stationary, or it comes back from where you applied a force, that means there must be an opposite force. So
we heard it, Rumpus. Let him play further.
Yeah, let's do. Please do me a favor and shut the fuck up until the 6-minute mark at least.
The word force, though, Alex, for a long time.
14 seconds. We gotta wait. He's gonna say.
Yeah, we gotta wait at least 14 seconds.
But you need force to make it move, right? If you haven't got anything physical, if you haven't got something that you can point to prove, to manipulate, to vary, you haven't got a force. You've just got a disequilibrium that will resettle. That's all it is. But you need that force, that interaction, as per the definition. Otherwise,
okay, let's stop here. We actually already proposed a way to manipulate the force. First of all, by going into the vomit comet and completely eliminating it, or second of all, doing this entire experiment in a centrifuge.
Yeah. That would add to the forces.
Yeah, obviously it would increase.
Oh, that's still manipulative.
But it would change, the net direction of the force and the net amount.
Plus, he's about to cherry pick the definition of force. You're gonna love it.
Oh, in fact, that's a really good point, actually, Alex. If you
shut up, Rumpus.
just a quickie. If you were in a centrifuge,
no such thing with you, Rumpus.
Sean suggested if we put this in a situation of centrifuge and span it really, really quickly, effectively would be changing the weight of the mercury relative to the thing, and it would actually become more buoyant. So
exactly.
So you would actually be because you
wait, stop. No.
It depends on how much.
It depends on what you mean by more buoyant. Obviously,
the force upwards would be greater because the effectively increasing G. If you were to put it in centrifuge so faster and faster, you'd effectively be increasing G. Like the weight is dependent, and therefore the relative.
But the ratio of the densities would still be identical.
Yeah, that's be identical because the little g is in both equations. So manipulating
that's why we can use centrifuges.
The ratio of the part of the anvil that is submerged and the part that isn't wouldn't change when you change the acceleration.
You're absolutely right, Alex.
But just to say, here's what you could do. You could do the math to calculate what the force on the centrifuge would be putting onto the anvil, right? And then you could run the experiment, find what the actual force was, create the vector, and you could work backwards to find out what the force pulling downwards is. And that's your gravity right there.
Maybe don't do it with an anvil. That's a very large centrifuge.
For everybody trying to do this experiment in the vomit comet, don't put liquid mercury and an anvil in the vomit comet. I know several reasons why that's not a good idea.
Yeah.
Especially because the vomit comet is probably made of aluminum, and you know what happens when mercury gets into contact with aluminum.
Yeah, it's a bad idea.
Yeah,
I'm more worried about the people.
Yeah, not to mention the anvil is accelerating at 8.9 meters per second squared, and then when the plane
actually
levels out, it's still it's accelerating at 8.9 meters.
I'm still more worried about.
You can't accelerate more. It's going through
9.81. That would mean that you would be constantly still falling at a constant speed, yet no longer being in free fall.
9.8 meters per second squared.
Yeah, sorry. If you accelerate upwards, you have to be over a little bit over 1g, which is what you feel, for example, in an elevator that's moving at a constant speed. When you're moving at the constant speed in either direction, you're feeling the 1g. But when the elevator is slowing down or starting, you're feeling more/less than the 1g. And that's directly analogous to what the vomit comet is doing after the weightless period is over, after the free fall period is over. You will feel more than 1g, a little bit more.
Oh, yeah. That's what I was saying, that the anvil would go straight through the fucking plane.
Yeah, probably straight through the floor, depending on where it is at the moment.
Still more worried about the mercury.
More bullshit.
Yeah, me too. I would be worried more about the mercury. That stuff is more dangerous. At least in the long term.
More bullshit.
You haven't got a force. So remember, force, strength, or energy as an attribute of physical action or movement.
How about you use the scientific definition, you dumbass?
Yes, let's do that live. Let me share my screen.
I already did.
Yeah, wait. Definition.
I've been picking at the cherries.
Oh no, I found a better one. Force is a push or pull upon an object resulting from the object's interaction with another object. What's the fucking formula for it? The Newton. Yeah, whatever.
Excuse me?
Is that good enough?
Oh, that was lovely. I feel better now.
Did you know that Aristotle looks like an old Riley?
That's disturbing.
What?
Aristotle looks like an old Riley.
Wait, shouldn't it more be that Riley looks like a young Aristotle? Since
yeah, but that tends to be a little more complimentary.
Well, yeah, but it's still more correct considering that Riley came afterwards.
Look, it's Aristotle.
Do we really want to think about Riley coming anywhere?
No, not really. Thanks for that image.
You're welcome.
Life reeks of purple butters.
I think I just made my own. I think I just made my own vomit comet.
I did show you the planned thumbnail for this hangout, didn't I?
I did.
Yes, I
Yes,
saw
I
it.
did see that.
Okay. Yeah, just putting that out there. Let's continue. And actually, let's let this video run till the 7-minute mark, I guess. So 37 seconds. Can you handle that?
We'll see.
2 of 3.
Because we have something happening, it's moving downwards, and we need to at least ask, why is it moving downwards towards the Earth consistently, always with an up-down bias? And people don't want to answer that question, or they insert, oh, density and buoyancy takes care of that explanation. How? There's no way that density and buoyancy, two things which invoke like qualities of mass and buoyancy involves so many other forces, like force upwards versus the force downwards, or how much of the water is displaced. It's all in terms of weight. So buoyancy is not an explanation either, and people keep parroting this statement. Oh, density and buoyancy explains it. It does not. I'm sorry. I've never heard anybody tell me how density and buoyancy explain a motion, an acceleration, which is downward.
No, this
Stop.
Asked
So
and answered.
she's asking the exact question that we've been asking them for how many months at this point.
Yes.
Density exists whether gravity is a thing or not, because it's simply the amount of mass an object has divided by the amount of volume it has.
Yep.
However, buoyancy is a force, and a force can only be a thing if there's an acceleration going on. And there's no direct correlation between something having a density and a force being applied on it in any direction. So that's the question. Where does the fucking force come from? And hence, where does buoyancy come from?
From midichlorians.
I win.
This is embarrassing. I've told you myself many times we can explain everything with density and buoyancy. But it's not just density and buoyancy. It's relative density. Okay?
Stop. Okay, so you have two different solutions with two different densities. You can divide the densities and you get a ratio. So
Yes.
what's the point?
Yeah, I was going to say relative density means nothing. It just means a comparison between two different densities from the perspective of one or the other density. Relative density, for instance, let's say you were looking at 2 and 3, red and blue. Relative density means from red's perspective, blue is more dense, and from blue's perspective, red is less dense. Like there's nothing going on there. There's no descriptive force or anything. There's no application of a force anywhere. It's just
that
talking
alone
about the
doesn't-
description.
Yeah, saying which one is more or less dense doesn't tell you by default where they should be ordered.
And
Because
let's also not forget that relative density does not is not locked to two things being next to each other either. You know, I could have, you can have a relative density. You can compare the relative density of an egg sitting next to a can of soda. Just because you got stuff in a beaker or in a cylinder there, that doesn't exclusively mean relative density means things that have to be next to each other.
Anything else to add?
No, I'm actually looking for something for the audience that have kind of half-handedly made a request. I just have to find it.
Okay, then anyway, let's just continue until maybe 8:30. So that's 49 seconds.
Well, again, all of these liquids are all in the medium of air. Air has got a density value of about basically 1 kilogram per meter cubed. 1. But you can see that all of these have got numerical values. So what we'll do for the purposes of this demonstration, Nora, we will give the value of 0.5, just so that you've got the number, the relative number that all of these are in, because all of them are more dense than the air that they're in. If they were less dense, like helium, they would rise. The order is caused by the density. of the matters in question relative to the medium. It's not always in an up and down either. Can you see that any of them numbers, say milk number 8, if you were to start pouring that milk in, and you didn't have any milk in between 7 and 9 before, and you were to inject it with an injector, and you started to fill it up with a bit of like more and more milk, it's not just up and down, is it? It's left and right, and it fills the container. So it's filling the medium where it finds its level, its equilibrium. It's caused by the density, Nora.
Stop.
That
Okay,
has nothing to do with that.
Yeah, first of all, the relative density is quote unquote that he's giving here. Obviously, the top layer with the label 2 is not fourth the density of number 8, which is what he kind of hinted to, didn't he? Or am I misunderstanding what he said?
I'm honestly not sure what he actually tried to say there.
Actually, he just, I think he's drunk because the milk bit comes in a second. You'll see, and for some reason he associated that with the number 8, which I have no idea.
No, it's because of what's on the screen.
Well, thinking about milk and injecting, I hope that this really is milk.
Right. That's bull milk.
Oh God, no.
Well, that has a different density, though.
Seems to be more like bullshit.
Well, no,
yeah. Wait, what do you mean? How do you know? Because I have seen sperm and I have seen.
He's actively milked a bull.
Seen milk, like I'm familiar with both liquids.
There's nothing you can say to save yourself, Micro.
I'm not trying to save myself. I'm literally trying to explain explain why I know that.
But yeah, I don't understand what he was talking about the inserting the milk.
Yeah, he's saying that if you inject it with like a syringe or something, it will automatically orient itself or sync between layers 7 and 9.
Well, all he was saying is that he seemed to think that you couldn't just pour it in the top and it would then find the relevant.
I mean, obviously, you could just pour it in the top, providing
so that's what he thinks. He thinks you've got to inject it into the right one.
Layers, right? Still has to overcome the surface tension forces between the layers.
Yeah, that's really all he's really talking about. He's just trying to avoid messing up the stratification and have to make its way down gradually and mixing. Potentially could react in some way. You know, maybe it could become miscible or something.
There's actually a technique in chemistry that I use every now and then. It's called layering, in which you dissolve an impure compound in a solvent in which it's nicely miscible. So dissolve it in like something like polar solvent, like for example THF, tetrahydrofurane, and then you add a layer of pentane. Now those two layers are actually miscible. They just have different densities, and if you do it cautiously, those layers will actually not mix. The thing is that your compound, when it's not soluble in pentane, it will start to crystallize nicely in the mixture.
Right.
This way you can get really nice crystals out of impure compounds.
No, off topic, but people in the chat were complaining that Anthony's picture that he had on his video was not the correct one. He apparently had a mouth. So I have the correction for his video on screen.
Yeah, let me share you for a second there.
So yeah, there's for the people who were complaining that Anthony's face wasn't quite right in his video.
You realize, Sean, that now you have to play his theme, right?
Jared, you have it right.
I do. Actually, let me check. I think I still have.
Oh fuck! I just saw Sly's screen. That's fucking awesome.
Of course, I got an immediate thank you for showing Anthony's true face. The purple dildo's in his other anus.
Okay, let's continue to maybe 10 minutes.
No, wait, hold on. Because he also seems to think that the buoyancy has to do with moving left or right.
Yeah, you're gonna love that.
Yes, I mean obviously this would also work in a 2-dimensional system.
No, but like if like perpendicular to gravity.
Yeah, so he does kind of understand that.
But that's not like the buoyancy isn't responsible for moving it left or right.
Well, right, that's just the ideal gas law, right?
Well, I pointed out to him on his channel.
We're dealing with liquids
well,
here.
Yeah, liquids.
Yeah, the liquid law.
Same principles.
I pointed out to him on his channel that if it wasn't for the rigid structure that those fluids are in right there, they would all be laying flat on the table and not on top of each other.
Geo, damn you.
I had to make that joke again. I know it's boring. Okay, anybody else got something, or shall we continue?
Continue.
Okay, 10 minutes.
And it's relative to the medium it's in. So if the milk didn't exist in this liquid solution, and then you inserted it, doesn't matter where you put it, it would find its level relative to the mediums in which they're in. Once it finds that level, it'll settle. That's it. Not always
Gio,
up and down, Nora. It will go.
Yeah.
Does that gradient cylinder represent a solution?
No. At this point, no.
Okay.
You know what would be really tricky? Is to set
really
that, it would be really tricky to see somebody set that on a turntable vertically and let the centrifugal force pull it all vertical. That would be really cool.
Well, horizontal, right?
We do have a good question from Mika in the chat. How many birds wide is that container?
2.6.
And you need the units.
2.6 birds.
Who's on the ventilator?
Who's slowly dying? Yeah.
We all are.
Some serious arrhythmia going on there, dude.
Well, taking a look at so many Riley videos, I wish I was dying.
I'm waiting for the solid tone.
Yeah, ding.
And well, by the way, death jokes are okay again.
Oh, okay. I didn't know they weren't.
Yeah, well, because of the.
Oh, okay.
Yeah, you know. Okay, let's continue.
Because of death.
Because of Michael Jackson's death. It's been long.
We'll go with that.
Yes.
Hee hee.
That was terrible.
That was so weak.
That sounded more like a cartoon character laughing.
That was so weak I didn't realize what it was supposed to be until just now.
Okay, 10 minutes.
See as well. Exhibit 3 of 3.
When you presuppose that you have given a reason for the falling downwards by naming its quality as being dense, or saying density and buoyancy, which is just an ad hoc nonsense that is applied to the phenomenon of something falling downwards.
No, Nora, it's not an ad hoc nonsense. It's well explained. It appears that you don't understand it because you seem to miss off the relative aspect of it. Remember, it's relative to the medium it's in. It's not just density buoyancy. It's not ad hoc, and it's not nonsense.
Can I ask something real quick?
Yep.
Okay. Is the lady Nora? She's also a flat earther, but she just believes that there's a like an eternal down, right? An up and down.
I don't know.
Okay, I think that's what Riley was saying at the beginning. And if that's
but you really gotta trust him.
Well, yeah, I know, right? I don't know who the lady is. So if she is a flat earther, then she's presupposing up and down the same way that she was complaining about flat earthers who use buoyancy and density are presupposing their properties.
Yes, but obviously she's still understanding that a net force is required.
She's according to Riley, she's calling it the eternal force of down.
Yeah, but even that's better than not understanding that the force is required at all.
Oh yeah.
Well, because Riley and the whole Nathan show was having an argument with what's the name? What's the dude with the accent?
Rumpus.
Which one?
Sorry,
a lot of us here.
Yeah, no.
I mean, technically, everyone in the world has an accent.
Shit. I forgot his damn name. The one who believes that everything is kind of like magical almost.
Oh, Arwin.
Which one?
Arwin. Yeah, they were having an argument with Arwin about 2 or 3 episodes in a row when he was trying to get Riley to say, yeah, but what aligns everything up and down? And Riley would not answer him.
Argon rays.
Yeah.
That's just their weak argument for gravity, because they at some point they have to accept that there's a force. There's too much evidence to say that there's not a force, and gravity, our explanation of gravity requires it to have large bodies of mass form spheres. So if it's a downward force, then you can use gravity to be a plane instead of a point. So it falls in line with their worldview, but it also takes into account gravity.
I mean, infighting between philosophers is always a hilarious thing to watch, isn't it?
I caused
Who's
the biggest
more
infight.
wrong?
I caused the biggest infight to date, and I'm so proud of that. Square miles or miles squared?
Oh, I remember that. Oh, that brings back painful memories.
Oh, that was so glorious to see them all just destroy each other over that. Because none of them knew that there was a difference. Until Anthony actually looked it up and he brought up the whole topic.
But let's be fair, they don't know how to convert meters into kilometers.
That's always been a thing. And to Nathan, everything's 80 miles away.
Okay, let's continue until 11.
The other thing that you seem to mention, or miss rather, is that every time that there's an object that falls downwards, there is an equal and opposite reaction that something else goes back up the other way of the same size. So what you perceive to be...
Stop!
Does anyone know the name of that force?
I think what he's actually meaning is that when something is sinking, for example, in these fluids, the fluids themselves will be pushed upwards. But there are two things.
Yeah, otherwise, you would have a vacuum.
Exactly. What the fuck happens in a vacuum?
Well, the vacuum fills it, and the vacuum has a density of nothing. So it fills all spaces.
That's one thing, and obviously, it also
just broke my brain.
It also doesn't fill spaces. It apparently also fills his head.
That's a space.
Again,
are we sure it's not just bone all the way through?
His purple buddy fills up a lot of spaces, so...
No, those aren't spaces. Those are orifices.
Hang on. Was there talk about a vacuum and pressurized systems at some point?
Not in this video, no. Oh, yeah. This joke is terrible, but I have to share it anyway.
We finally found the elusive vacuum next to a pressurized system.
Nice.
For fuck's sake.
That's so awesome. Prove us wrong with that, bitches.
Okay.
Photographic proof.
11 minutes this time.
It's CGI.
Be the thing that falls down, you're missing the other thing that's going back up the other way. That's the proof that it's a balancing act. It's an equal.
So he apparently does understand the third law of motion?
I don't think that's...
He's just a dishonest twit.
Yeah, I don't know. I don't think he actually understands it. I think he's just like, from what I'm like, the way he's saying it, I think he's just like trying to explain buoyancy and like fluids filling up spaces in his own weird way. I don't think
he's doing everything to avoid the term net force.
Possibly, I'm not sure he actually understands that.
Oh, he does. That's why he tries to. He does his best to shut down every conversation that brings up net force. He shuts it down immediately.
He doesn't understand that, Sean. He really doesn't understand that. He doesn't understand that. He doesn't think there's any forces happening. if he did, I mean, no one who could understand Joud's simple density equation could think, where's the force coming from? There is no force part of that. He doesn't believe there are any. Well, he does. He sort of introduces it when he's sort of, they're pushing on the anvil. That he thinks there's a force to move that, and presumably he must. Perhaps he doesn't understand that, for it to come pop back up again, there must be a force. A buoyancy. I mean, he doesn't believe that buoyancy is a force for a start. He sort of mixes them in and mixes it out, and he certainly doesn't understand the concept of there being two forces. And I went through this on some occasions when you're trying to do pulling a rope, tug of war teams. That you've got the net force is you've got two tug of war team. The rope is being pulled in two directions, and then obviously dependent on which one is pulling harder. But he doesn't understand that if the two teams are pulling equally hard, the net force is zero, and he thinks in the neutral buoyancy case, there's just no force.
I had a hangout with Hector, one of my really early ones, where we tried to explain to Riley how a pendulum works.
Yes.
And one of the major flaws in his thinking was...
I was waiting for you to bring that up.
He was mixing up momentum and force.
Yes. Didn't he in that hangout say that when
What?
Didn't he in that hangout? Didn't he say that when the pendulum is at the top of its swing, there's no gravity?
And
there's no acceleration.
When it's in the equilibrium, meaning that then when it's on the bottom position, there's no gravity.
But we also in that hangout, I think, like, we went on to like the example of throwing a ball, and he basically said that when the ball was at the top and like its maximum, its apex, there was no acceleration on it.
Yeah, he also said that basically if you have a pendulum, when it's at the height of its swing, then there are no forces acting on it when it reaches that point.
Yes, for those who don't know.
So I was going to say, he's not saying that there's no acceleration, or you're not saying that there is acceleration when the ball reaches its apex. You're saying that he's saying that the acceleration force is not even there.
Yes, he says that when the speed is zero, the acceleration is zero.
Guys, you are all operating under you guys are all operating under the pretense that everything that he says is consistent.
he just doesn't understand any of this. He just mixes up words and ideas that contradict one another. And he's just not aware of what the hell is going on.
Hold on, Sly. Are you saying that we're presupposing IQ?
No, actually, wait, no. Actually, what I'm doing is I'm actually supporting his argument about education, about how everything's in repetition, and it shouldn't be in repetition. Therefore, he doesn't make the same points under the same logic about the same things fucking ever.
I mean, this is a guy who denies that scales prove gravity. I mean, this is the extent of this idiocy here. I mean, he doesn't believe in gravity. He doesn't believe in scales showing gravity. He doesn't even. He's actually said that scales do not show force. I mean, the guy has got so many problems in so many areas. We've got to fill in 5 years or so of education he's missed out as a teenager. I mean, it's just ridiculous.
Yes. This is why I say if he goes and spends that 2,000 pounds on basic science books and just reads them, don't ridicule them, read them and try. If you think they're wrong, read them, understand the ideology that it's trying to express, and then point out the flaws in the idea.
Not ideology.
Yeah, I think ideology is not quite the right word.
Well, philosophically speaking, right? Like in all science is based on philosophy, right? We were just talking about the presuppositions that the universe exists.
Yes, that's not an ideology. I think that's a philosophical basis for your position.
We understood what you meant.
Okay. Yeah. The idea is that break those down and prove those wrong.
The ideas in there. Yeah, that's right. Yeah.
And by the way, there are scientists actively every single day testing against all of the theories and all of the structures that we have in physics anyway.
Yes, because proving them wrong would be
Nobel Prize.
Yeah. I mean, because if somebody turned around and disproved E equals MC squared, let's just say it, and I would bet every dollar that I've ever made that there are people out there right now trying to do that.
Yeah, there are people who try to prove that lost in light.
And I'm talking about legitimate physicists. I'm not talking about conspiracy morons.
Yeah.
I mean, there are legitimate physicists out there who are actually testing every theory that has ever been brought forth, every principle, every law that has ever been brought out. Yeah. And what do you call it? And if they didn't test them, we'd be wrong for not testing them, quite honestly. But what do you call it? But those things get tested every day. I mean, there was a time when people thought that flying faster than the speed of sound was going to destroy the aircraft. Thank God somebody said, well, let's go ahead and test that.
Yeah.
You know.
Well, at a certain point, they were pushing the stress limits of the airframe.
Well, no, of course, no.
but-
They just meant like completely, as in the aircraft would fly apart.
Possible.
And it's not even that you have to go so extreme as to prove the people that have made like major accomplishments in science. Geo and Micro have to go in and actively validate what they're taught in the classroom every time they go into the lab, because they use that information from the knowledge base they get in the classroom and apply that to real world scenarios. If it didn't work, it wouldn't work. There would be no prediction capability.
My mindset is in parody mode right now, so please turn that off because I'm thinking about doing a parody of The Warrior. I've already got the first fucking verse, you asshole.
Yeah, I could do with that. I could do with not looking at that.
Can you keep it up then? I wanna hear that.
I haven't had a problem with
Hey,
it.
I'm sorry. I'm not the one who clicked present to everyone.
Yeah, bloody.
Here, I will give you all something better to look at.
Uh-oh.
This is what's on my second screen right now.
May I make that Ducati joke again?
Go for it.
The Ducati. Designed by the Italians and built by the Germans, just like fascism.
And what's funny is this is a 2005, so it was right after Audi bought them.
Well, technically, VW bought them.
Yeah.
Oh,
well,
and
VW at this point.
And Jared, I have a correction on last time you and I were going to hang out together. That was the 700. It wasn't my bike, but I had to check.
It was the 750. Okay.
No,
okay. Let's finish the video and then talk about bikes and whatnot. Okay.
1 minute.
An equilibrium. That's it. Why is it always the thing that goes down, the thing that you see and cite as proof of some kind of whatever? But you never mention the equal and opposite reaction going back up the other way.
Stop.
Come on, Nora.
Yeah.
So he's acknowledging that there is a strict up and down, something that he contested right at the beginning of the video.
It's funny. God, it just upsets me when they acknowledge it under certain circumstances. Only when it helps their argument, they will acknowledge.
Yeah, but even then, it doesn't help their argument.
But he opened his video saying that she was wrong about there being a strict up and down, and he just got done saying there's a strict up and down.
Mm-hmm.
A force in one direction and an equal and opposite force in the other direction, up and down.
So Riley, again, this is why I'm going to give spoiler alert. My next parody that I am actively going to work on is Walking Contradiction. And you are the star.
Yeah. You should make a parody video of it called Wank Like an Egyptian.
Actually, I've
that already exists.
I've had plans for 2 years to do that song, and it actually has to do with Eratosthenes.
Sorry.
Okay, continue. 45 seconds. We can do this.
It's really simple. It's relative density. Unless you can prove that there's an extra force, it's just a story.
Stop! I hate myself for stopping. But whenever we show him an external force, namely gravity, he will just reject it. We've shown him the, how is it called? Fuck. Cavendish experiment.
Yep.
How many times now?
They dispute it's not an experiment. They claim that it's a trick, a parlor trick or something. As they
I mean, Hector's fucking done it live from one of our lecture halls where we have one of those setups.
Again, if he doesn't understand that there's a force creating his density tower, make yourself a goddamn centrifuge. Input another force and see what happens to the direction of the stacking.
And you
it's
can
that
even
simple, Anthony. You're too
and
much
you
of a
can even
retard.
use fluids that actually do mix together and separate them.
But that's very hard, Sly.
Not really.
Yeah, but yeah, well, it's better to just submerge a solid that floats in the liquid in a way and separate it that way.
I mean, I agree with there's easier ways to do it, but but you can. I mean, that's one of the reasons why they use them in medical labs, is to separate the parts of blood.
I mean, hell, Anthony, if you don't want to make a density tower, just get yourself a bucket of water and swing it fast enough where you can swing it vertically over your head and watch how the water doesn't fall out.
But
again, don't do that with mercury.
Sly, when you separate the components of bloods, you're not separating different liquids.
Right, but they were at one time together a solution.
Yeah,
yes,
but
yeah, you're talking about
the red blood
like
cells.
a heterogeneous solution, right?
Yeah, it's not really.
I didn't catch a single word because everybody was talking at the same time.
Okay, so blood. Just want to point out that blood is not made up of several liquids. It's made out of one liquid and a bunch of solids. Well, floating things floating in it.
Yeah,
well,
it's
yeah,
not
but I
mean. It's not a solution. Yeah, suspension. Yeah, it's not a solution.
Yeah, you could say the same thing about, I don't know, various other stuff. You know, like if you were to take something powdered and put it into water, those molecules still exist.
Oh, well, if that dissolves,
no, but it's just that you said that blood was like liquid. Several liquids.
I was saying of different components, and you can separate them.
Yeah, but if you had a sugar solution, if you had a sugar solution and you span that around in a centrifuge, which was still in solution, you would get an increased solution density in the bottom of it.
But you will not obviously crystallize the sugar or anything.
Yeah, that's the problem.
No, of course not.
Well, that sounded a little bit like you could completely separate them. Sly with solutions, you cannot do that. Not very nicely. Okay, 36 seconds. Oof.
Stop telling.
Oh, sorry, my bad.
Story. Stop misrepresenting the counter argument. It's not just density and buoyancy, Nora. It's relative density. If you have liquids or gases that are miscible, they are miscible. They will mix. If they're immiscible, they will not mix. That's where you get your perception that it's up and down. It's not up and down, Nora. They're just being separated because they can't mix, and it'll be caused by the fact that they've got different densities. That's it. Come on, wake up.
I've got to talk about relative. His favourite word is relative. So, for instance, he thinks that gravity is relative. What he doesn't understand is it's relative to you. So, for instance, if you use the word that gravity is relative, that means that it's going to be in the same direction relative to your coordinate system. So if you think gravity acts towards your feet, that means if you turn yourself upside down, stood on your head, gravity would then still act towards your feet, and you'd be going upwards. He doesn't understand what the word relative means, which is one of his many problems, but it's a big problem, and he just loves to use it. And he will say, but the gravity is relative. He uses it as an argument for almost anything. And he doesn't really understand what relative means. And in things like gravity, it's relative to your coordinate system, and if you rotate yourself, you're rotating your coordinate system, and therefore, if you've got a force that's relative to your coordinate system, it's going to maintain its position relative to you. So if it's going down towards your feet.
To be fair, Rumpus, he got the whole relative gravity thing and relative direction from not his own research, quote unquote. He got that from Nathan because Arwen was talking about how there's a force pulling things down, but he doesn't want to identify it as gravity. And Nathan jumped in relative to what? And that's where the whole relative gravity came thing.
Right.
Thinking.
Okay. Right.
That came from Nathan.
Right. Oh well, whatever. He's taken it on board now and loves to use it. So yeah, okay. He's adopted it and appropriated it and dispenses it.
You said gravity relative to what?
Right. So he will say that there's no absolute up and down. So if you say to him that there's an absolute up and down, he said no, gravity is relative, which he thinks is some way of saying there is no absolute up and down. That's right. He says there is no absolute up and down. So there is no. If he says there is no up and down.
Well, I don't sleep on my feet. I sleep laying down. So why am I not flying into my wall?
Yeah, exactly. But he doesn't realize that's a consequence. So what he will see if you say to him, "There's no absolute up and down," which he claims. So there's no up and down. He's saying no, it's not absolute. Although he doesn't quite use that word. He says it's relative. Up and down is relative. This is one of his favorite phrases. And if you understood what that means he's implying it's relative to him, his coordinate system, the way his body plan works. Relative to you means that, if you take your feet as the bottom of you and the head at the top of you, relative to you, that means that gravity is always going to have the same position or direction relative to your coordinate system, which means if you say that gravity is relative, the force is relative that we describe as gravity, that means if you stood on your head, then gravity is going to start pulling you up. And of course, that's because he doesn't understand what relative means. He just doesn't like the idea of there being an absolute up and down, which of course there is, because there's an absolute in space pulling you down to the center of the Earth.
Skeptic, there's a thing that people hate me at work for. Every time they see me in the morning, they'll say, "What's up? Ask me what's up."
What's up?
No, seriously. Ask me, what's up? The direction directly opposed to the pole of the local gravitational field.
Very good, Sean. Very good.
Nice. Okay, so now that we've dealt with Riley, is there anything else you guys want to talk about? Sly, you had mentioned you had a conversation with
Quantum
Eraser.
Oh no.
Would you like to share that, maybe?
I'm just going to say, no, I didn't have a discussion with him.
All right. What kind of interaction did you have with him? Have with him?
I'll just say him came to comment section and shitted everywhere.
So Quantum Eraser activity.
Did you want to talk about inferior mirages at all, Sly?
Yeah, thanks for giving Riley that.
Yeah,
sound
sorry
bite,
about
dude.
that. Yeah, I'm sorry about thanks, by the way, for the comment you were saying about you didn't want to give Riley a quote that he would then misuse. Because, by the way, if Riley did relate to me that he'd said you would call me a liar, my reaction would be, Sly doesn't do that sort of thing, but you do. So don't worry. If Riley ever came to me and saying that you would slag me off in some way,
I love the fact that he came up and in my hangout and he was like, well, Rumpus said. I said, well, I don't care what Rumpus said. Okay, and now that's not meant to be a hit or anything.
That's exactly right.
But it's like that's not my argument.
Exactly. He's got to make his argument.
If you want to argue something that Rumpus said, then bring it to Rumpus.
Exactly.
You know, and right. What do you call it? He keeps on because he's done that before a couple of times, and he's always said, "Oh, Rumpus called you a liar" and all this. I said, "No, he didn't." You know, and if he did, if he did, then show me. You know,
exactly.
and then
of course we both know what Riley's like and that he's going to misquote. So I just completely dismiss any.
And he turned around and he decided to make light of the fact that you and I were having a dispute about terminology.
Exactly, this is a discussion.
And he's like, "Look, they don't even seem to agree," and all this. Man, motherfucker, shut up.
Yeah, I've got on screen here what I wanted to. Can you see that?
Here we go.
What Riley doesn't understand, and this is why he tries to pit you and Sly against each other, Rumpus, is you know more about refraction than Sly does. You've actually taken the time to learn about refraction.
Now, wait a minute.
I'm just using you two as an example because that's the current topic. Because it is true. You know a lot about.
You trying to say Rumpus knows more than me, man?
I'm saying he's putting in a lot more legwork.
I tell you what,
legwork. I'll give you legs. Hold on a second here, man.
I just like to say,
skip leg day.
It takes me about 5 times as long just to draw a simple, nice, pretty diagram that I know that Sly can do without even thinking about it. I really struggle to make something look nice in my mega presentation. And I just keep on thinking, I wonder what Sly would do here, because I know he'd be able to draw things nicely because he's consistent. And I just can't. It takes me ages.
It takes you ages to shut up.
Sly.
Yeah. I was going to say that.
How good is your computer? Is your computer like a top-notch computer, can run like good physics animations?
It holds its own.
If I would like to share something with you here in the side chat. It's an animation I created using Symmetry. Are you familiar with that program?
Yeah.
Okay, I created a
mildly familiar. I know it exists. Let's say it that way.
water attracting to a ball and conforming.
Sweet.
But I can't run it on my computer and show it to people because my computer is just not that good.
You don't even need Symmetry. Go ahead and get yourself Algodo.
Algodo?
Mm-hmm. It's free.
It sounds like a Pokemon.
Algodo is a lot of fun, man. And,
what's its evolved form called?
What's that?
What's the evolved form called?
Of Algodo?
I'm looking it up right now because I want to get it.
Yeah, you're not. I have no idea what you're talking about.
It's Sean. It's called Hulk.
It was a Pokemon reference. Come on.
Okay, sorry. I found that.
No,
Algodoo.
Yeah.
How could you? I choose you.
And look, speaking of which, this is something now somebody was actually asking me about. If you drilled a hole through the earth, what would happen if you fell through it? Would you shoot out the other side, or would you go in the middle?
Share your screen.
Yes, great. I love that. I love that, Sly. I love that, thinking about that sort of thing.
But obviously, you will fall through it, and then
he stopped sharing his screen when you presented him.
No. I was
the same.
We were pushing buttons at the same time.
From one point down through the Earth and back again. The same time it takes to orbit the Earth at the same altitude.
Okay. Well, here's the neat thing. This is a circle which gravity has been applied to. Okay, and attraction has been applied to. Now I'm just dropping this little guy right here out of the top. there is no gravity turned on as far as a common up and down here. So it's basically the only gravity or forces are right here on the side pieces here. And if you hit play,
the 2 X's are the centers of mass.
No, the 2 X's are just holding these two parts in place. Those are
so those three, right?
They're just bolts. This is in 2 dimensions.
Oh yeah, right.
And if you let it go, I put a little tracer on it. If you let it go,
damped.
Bing, bing,
nice.
Bing, bing.
So you've got some damping on this.
Well, yeah, would have to be air in the.
Yeah, there is atmosphere. I can turn atmosphere off. Hold on.
Oh right.
Can you do me a favor, Sly? Can you at the same
I was
position where
I was going to say if
your ball is?
that's not what is predicted by.
Okay.
Oh.
Go ahead.
Sly, can you do me a favor? Can you restart this entire thing? So stop it.
Okay.
Place the ball, the test object, the one that's falling a little bit further up.
Okay.
Okay, now put a second test object in orbit in the same height around this entire thing.
Hold on. In orbit?
Yeah.
Oh man, you're gonna need a while for me to get the velocities right.
Because if I remember correctly, the 2 periods for both objects to travel through this should be identical.
I think you're right, actually. Yeah.
I don't know that. And like I said, that would take me a minute to get the velocities right, just by the way you set up those velocities.
Well, will it take you about a minute to get that set up?
No, it'll take a little longer than that.
Oh, okay.
Yeah. So this has got damping. So it's actually allowing for the atmosphere and drag, right?
No. Atmosphere is turned off now.
Yeah, at this point,
it's still being damped. Okay, well,
it's just rubbing against one of the sides of the.
It's hitting the.
Well, the dampening that's happening here is that as it goes down here, the more mass becomes behind it, and the gravitational pull from the mass behind the object, as it's, let's say, when it's going down here on this screen.
Well, hold on. It should appear exactly as far below it as it started off above it.
He's right. Dampening shouldn't be caused by this.
No, the dampening here is caused by it hitting the sides.
Well, it is hitting the sides. I'll give you that.
Is it? When there's friction in this, is there?
What?
There's not a way to keep it from hitting the sides.
I can just turn the friction off.
Then it should work. It should work perfectly, Sly.
Yeah, it'll go from top to bottom to top to bottom.
Hold on a second here.
But it might not stay. It might not.
Oh right, so it does have friction. God, I think I've seen this before. It's fantastic.
It might change. It might fall out of the hole then.
No, that's restitution. That's something else.
Yeah, this is the what they're talking about making to.
Oh, that's brilliant.
The idea is to one day make a train that can cut across. So it would take the exact same time for a train to cut across at an angle as it would for the train to go straight up and down in the tunnel. The full length, no matter what 2 points you put, if you had a train going across, it would take the same amount of time as it would take for the train falling from one point to directly to the other side.
Yeah, you see, as soon as friction is off, this movement will pretty much be indefinitely.
Right.
Now,
for the reason, think about it this way: there's a conservation of.
I put atmosphere back on. I put
conservation of energy.
Yeah, yes. So this object in the beginning has a potential energy that will be transferred into kinetical energy until it's in the middle between the 2 masses, and then be retransferred into potential energy. And since there's no losses in terms of friction, be it to the atmosphere that you had or the sides by just scratching against them, the movement will be eternal.
Yeah, you have just a simple harmonic motion, because there'll be no energy loss. It will just do it indefinitely. I think I've forgotten all about this. This is a great little thing, isn't it? You can do it for wonderful things like multi-body things, like atoms and things, and the gas. You can simulate, pistons and things pushing a collection of molecules and things. You can emulate some fantastic stuff. I think this is a thing I was thinking of. Yes,
I think if I don't put out a video for the next 3 months, it's Sly's fault for introducing me to this program.
Actually, Team Skeptic, you should try Universe Sandbox too.
I do. I have that one. I created my equinox observation video using Universe Sandbox.
Let's see.
And my solar eclipse stuff. I did that in Sandbox as well.
Watch.
I highly recommend that program. That program is badass.
Is Truth Seeker in the side chat?
Yes.
I cannot see him.
Well, is Enlightened Truth Seeker 101 the same as Truth Seeker?
No, they're
Just
different.
see it, exactly. Enlightened Truth Seeker 101 and a guide called Truth Mafia 36. But no
Enlightened Truth Seeker 101 I've had in a live stream before. He's not too bad. He's like kind of a truther, not really a flat earther.
No, but like
Skeptic, watch.
No, I just brought him up in the internal chat with Gio because he seems to have gotten have given up on a lot of his stupid. So good for him.
Hey, can you get to that Google Drive and open up the I think it's called waterball.exe because I actually model it out in 3 dimensions.
I'll try it in a second. See this. I'm applying gravity against a downward force of gravity.
Yeah. You have a downward force still going on here. So exactly how it should look right there.
Now I just turned it off. It even pulled up that other drop from over here.
Yeah.
Oh, brilliant. Oh, fantastic.
This program is awesome, man. I'm telling you, this is what I live for. This is life. This is amazing.
I do little buggies and shit in this thing just for fun.
Yes.
Can you put people on that sphere or a circle?
I want to play worms in
bendy water.
Oh yeah, worms with a nice
with a curve. Awesome. So you sort of have to shoot around.
Look,
there is a game called Gravity Wars. It was one of those.
I remember that.
Where you shoot from planet to planet.
Yes.
And they spin really, 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 really slowly.
The planets don't spin, I think, in this game, but it was nice back then.
Exactly.
Do this in 3 dimensions and earn a lot of money.
Can I just quickly touch on this inferior mirage subject, just to try and clear this up with Sly?
Oh, here we go.
Sorry, Sly. I don't want to. If you don't want to, let's not do it. If you don't want to, I mean, would you
go ahead, Ben?
So I don't want to. Yeah, I definitely want to slag you off or anything. I'm not slagging you off anyway.
I know you definitely wanna. So go ahead.
Well, I just want to clear. Just for your benefit and mine. But not trying to. I'm just saying that you were saying, I think you were citing, I think that in your video, a great video it was. Of you going over the brow of a bridge and
horizon of a bridge.
Yeah, the horizon of a bridge, indeed. And you then walk just over the other side of the brow, and you could see this, what I'm going to call an inferior mirage, I think is the correct definition. And I think you're claiming, and on the brow of the hill. So there's some examples, similar ones here. I couldn't find your video, unfortunately, but here you see each little brow of this road here. You can see screen shared here. These are little brows on the thing. You can see them from the side here. They're sort of
and that's inferior mirage.
Correct. Yes, exactly. And this is no different from your brow. The fact, this road could be going up and down.
Okay. Hold on. I totally agree with what you are showing there is an inferior mirage.
Okay.
Totally, 100% agree.
Great.
Now,
okay.
Let me show you where the mirage is occurring in the video that you were referencing.
Okay.
Okay, because this is the part I don't think you were really grasping a hold of.
Okay.
Now, see this mirage going on here?
Yeah.
Okay. This right here, the surface that you're seeing is actually the physical horizon of the bridge. There is the inferior mirage that you just showed, which I totally agree, that is an inferior mirage, is not present here.
Yeah.
Okay, now watch. I'll show you why. Okay, because this was the actual purpose of the experiment that I did here. Now, what I did was I walked out and I had a measuring stick with me. Okay. Now, what you're going to see, wait, actually, I got to wait till the point where I'm actually coming back.
You're back to legs.
Yeah. Hold on. Now, when I'm coming back, now you see all the mirage is going on. Okay, the mirage that you and I both agree is there. It cuts off about right this height. Okay. Now I walk up, and the whole purpose of pointing this out was to show that this type of mirage is only apparent or is only visible to things that are beyond the horizon of the bridge. Okay, now watch. Because when I get all the way up to the top of the bridge, to the horizon of the bridge, you will notice that there is no more mirage. As a matter of fact, it's getting less and less as I get closer to the horizon.
Yes, because it's going through your line of sight is not going through the inversion layer so strongly.
Hold on. Now watch. Now once I get all the way up to the top, you will actually see the metal tab at the bottom of my measuring stick here.
Yeah.
And then at that point, you will also see no more mirage as I am. See, I'm not even there yet.
Yeah.
I think it was this one that I actually landed right on it. Bam.
Yeah.
No, there's no more mirage going on. There's nothing below here like your truck thing.
Correct.
That is a superior mirage because it is happening above.
No. A superior mirage happens above. So hold on. What are you saying is a mirage now? Sorry. Where's the superior mirage you're saying?
Well, that's the point I'm making. Once I'm at the horizon of the bridge, there is no more mirage affecting me. Okay. Yeah, there's a little bit of heat wave. Don't get me wrong.
Yeah, still a little bit. Yeah, but fundamentally, you're looking through less of the.
But see, now that I'm over the thing, there's no inferior mirage going on in the bottom like in your truck picture. Okay, which I totally agree is real, and that is an inferior mirage. But superior means above.
Yes, but it means above the real image.
Right. And I get that, but this is about positioning of which mirage we're looking at. Okay. Now, as I go back, let me back this up. As I go back, the mirage becomes present.
That's right. Yes, but that's an inferior mirage.
No, because it's above the horizon, dude.
No. All mirages, inferior mirages, are above the apparent horizon.
But
so our little local horizon here, we call this little brow here a local horizon, and the inferior mirage is above the apparent horizon. Now the geometric horizon, because I've had a discussion with Sean on occasions where if you could actually use the plot of it geometrically, because of course there's a difference between the apparent horizon and the geometric horizon, although in this distance it'd be very close. The apparent horizon, where there's the layer of refraction layer, so it's obviously a heated here, and it's got an inversion layer, which makes it an inferior mirage. And then you've got the real image. And then when you had, if you could position your stick, if you had a little bit of your blue little tab and you could see it being reflected, the right-hand side of the bridge, for instance, you see that? See the right-hand side, okay, so I'll just finish here. The right-hand side of this bridge, you can see that it's curved round. That is a reflection of what's above it, and it's also compressed a bit, but it's fundamentally an inversion. Reflection's a bad word for it. An inversion of what's above it, and the line is about, I don't know what. Oh God, sometime just above where where's your purple, twice the height of the purple area of your legs. You could say that's where the inversion, what's called the what's the name for it? The folding line. The folding line is there, and it's in the above the stuff below the folding line is an inversion of what's above it, and that is an inferior mirage.
I'll give it to you, man.
Okay. Well, okay.
But you need to understand.
I don't know whether you're just trying to shut me up or you're agreeing with me, but
a little bit of both. But because just to be honest, but the whole point is that what is to be taken away from this video is not the discussion of is it called a superior or an inferior mirage.
Indeed.
Okay. What's to be taken away from this video is that once I get to the physical horizon of the bridge, which is actually 2 steps further.
If I can
hold on.
Okay.
And once I get to the physical horizon of the bridge, there is no more mirage.
But that's because it's less curved. Where you are here is clearly a bit less curved than it was before, and you're also nearer. So the opportunities for refraction are much less.
Now you and I is going to fight because I'm going to say that this is a perfectly curved bridge.
Okay.
And that's why I selected it.
Right.
And, what do you call it? And what's being shown here is that the mirage does not start to affect any imagery we'll call it inferior, superior, we'll call it superior, okay? Does not, the superior mirage that's going on here does not affect me at all or the horizon until I am beyond the horizon on the descending side.
Well, actually, I think you'll find it is actually affecting. If you were to do the same test in a completely cold, non-sunny day, you would find that it would look a little bit different. You would have there is an inversion layer, and even this side of the brow of the hill, even if it was completely flat, for instance, if it was completely flat, what we're looking at here, and you had you were a long way away, so you got refraction, you got a chance to do them. You've come quite a. I don't know how much closer you've come, but the
come
curve.
To a point, Rumpus.
Sorry.
Please. Come to a point, please.
The more distance, I don't know how far are you away from the camera to your feet? Are you close to it on?
From the camera to my feet is probably about 30-40 meters.
Right. Okay. So when you moved away, you probably added on another 4 or 5, 6 meters. So you've given a greater length. The longer, obviously, the optical path of the light, you're going to get more opportunity. And also going over the brow of the hill, you're looking. You see, when you're looking.
Are you agreeing with me that the mirage, whichever one it is, are you agreeing with me that it is occurring beyond the horizon?
It occurs not always.
I'm not saying always. I'm saying in this video, under these circumstances, are you agreeing with me or not that as I am in front of the horizon, at the horizon and closer, okay, which is not here, but here, okay, there is no mirage going on obstructing or distorting other than a couple of little heat waves in the air.
Well, exactly. There's a little bit of going on here. This is why
that's not the mirage. Okay, that's just distortion due to heat waves.
Well, exactly. That's what a mirage is. It's just refraction.
Oh, Jesus Christ, man.
That's all a mirage is. With inferior mirages, all it is the fact that the
ground level stuff, buddy. The ground level stuff. Okay,
yeah.
I'm not talking about the fact that, I mean, there's mirage going on up here. If you look at the heat waves and the way that makes this move around.
Oh, now you're talking about turbulence, I think, aren't you? Now that's different.
Right. That's what I'm talking about. That's obviously everywhere.
Yes, okay? I'm not talking about turbulence.
I'm talking about down here at the ground.
Yeah.
The mirage. There is no mirage going on here. Otherwise, you wouldn't see the tab on my measuring stick. Okay, there's no mirage going on there. There would be a reflection from up here, which there is as I go further back behind the physical horizon of the bridge.
Well, that's only
and that's the point that I'm showing with this video.
It increases with distance, obviously, the miraging effect.
No, it doesn't increase with distance. It doesn't start until beyond the horizon.
No, it's happening all along your path. I mean,
it's not.
No, the key. The reason it's crucial because when you're looking at the horizon, that's where the inversion layer is greatest. So that's where you're going to get the maximum effect. Whereas obviously when you're looking, your camera's slightly not obviously at ground level, you're slightly raised, and when the light goes through the air that's very close to the ground, and it happens that on the local horizon you've got here, that's when you're going to get maximum effect. So that's why it appears more when you're I mean, for instance, you could say, okay, what about the bridge at the right hand side? That's not going very close to the brow of the hill, but you're still getting the inferior mirage where the fold line is about actually just to the where your instep is just about. There's the fold line.
And so what you're saying is that this is actually increasing with distance.
Yes.
Or okay. Well, I'm going to tell you you're also wrong on that. Let me tell you why. No, let me tell you why I'm going to. No, because I'm telling you why, because of the stuff that's in the footage. This bridge railing right here, okay, where it ends, or where it visibly ends, okay, that's probably about a good 20 meters behind me.
Yeah, but obviously
don't. And I get the same exact inversion height, okay, when I'm only about maybe 2 or 3 meters behind the horizon of the bridge. Okay, so if it were to increase with distance, then this fold line, I would never meet that fold line. The fold line on the bridge part here, which goes back, like I said, this is honestly about 20 meters behind me. This is the other side of the Autobahn. Okay?
Yeah, the fold. Yeah, perhaps when I said the fold line, obviously is in the same place, but I mean the effect of how much something is moved increases with the distance it away. So obviously,
right, and even then, I am showing you right here that when I go back, even about maybe I would say about 5 meters, okay, the fold line is equal. It does not get higher. It does not get greater. It does not intensify. Okay, with distance, it doesn't. It might distort as far as what you can maybe resolve as fine detail.
Yeah, turbulence. Okay. Yeah, we don't worry about that. The attenuation. Yeah, we're not worried about that.
But the height of this this fold does not get higher with distance.
Correct. Yes, I wasn't trying to imply that. I was implying
that's what it sounded like you were implying.
Yeah. Okay. Well, I didn't mean to. If perhaps I wasn't clear enough then.
Okay. But what I'm saying is that it will only become, as far as this footage right here, it will only ever be this high, no matter how far I walk back. Okay.
Correct.
It will only ever be this high with relation to the horizon. And then, you know, if I'm smaller due to distance, obviously it's going to look kind of weird on me, but that's about it. Now, the only point that I'm showing in this video is that that occurs and it gets smaller though, okay, and less as I get closer. You see how it's going down a little bit? Okay, and it's going down a little bit more, and then once I finally get to the horizon of the bridge, it's gone. Okay, meaning that the effect that you're seeing is happening due to the temperature shear across the sidewalk of this bridge on its downslope on the of the curve.
Refraction doesn't just occur on the downslope.
I'm not saying it only occurs on the downslope. I'm saying this, what you're looking at, only occurs on the downslope. It's happening beyond the horizon.
Well, yes.
Well, Rumpus, we'll have a discussion about.
Yeah, we'll have a separate. Okay, okay.
We've already given Anthony enough to play.
Yeah, we have. Yeah, we have. Yeah. Anyway, yes. Great video.
Thank fuck.
I'll put on this. I've got a presentation. When I do this final thing, I've got ray diagrams for this, and I will be able to show you with the ray diagrams for inverted things exactly what's going on. And yeah, perhaps we'll save it for that.
All right. So, does anybody else have a topic to talk about?
Well, I now have a tumor.
It's not a tumor.
It's totally a tumor.
I might have something that'll break up the monotony for 1 minute.
Go ahead.
He's gonna fart.
No, he's gonna. I think he's gonna play Riley's theme.
That's a long ass fart.
Wait.
Nope. Even better. Even better.
Sharing you.
That's a bike.
That it has one of those 120 degrees V engines, doesn't it?
90.
90. Okay. Yeah, a friend of mine has a Ducati Scrambler. I think it might actually be quite similar engine model. With one cylinder standing and the other one showing forward.
Yep.
Yeah. Okay. That's what I expected. Here you can see it.
Yeah. That's a lovely bicycle.
Yep, that's the motorcycle, all right.
Is that yours, Darren?
That's mine.
All right, very nice.
Oh, the one that will be had. I recorded that before jumping on the Hangout. Unfortunately, the audio for the bit that I was talking about wasn't quite where I wanted it to be, so I'm considering going through an editor and doing the audio aside from the engine note independently.
Nice VW.
And yes, Shadow, that is one of the original Desmo style engines.
There's no turbocharging or anything going on there. It's naturally aspirated, I imagine.
Yeah.
How much power does
it is fuel injected, but it is it's not turbocharged or anything. Why? Why do you need it? There's so much grunt in the low end anyways.
Just like every other VW engine, it's direct fuel injection at this point.
Are you sure it's not milk injections?
Well, hey, for those of people that didn't see my video I just put out, I'd like to share my Jesus clip.
Oh yeah, sure.
Here, I'm putting it in the side chat so that people can hear it. So whoever has the ability to play that through audio, play that through audio.
I currently actually don't. I was using my second account to simulate that.
Do you have it, Jared? Or do you have
I'm good. Well, I have the ability to do it. I just need to download the file quick.
It's small.
That's what she said.
Thank you.
I didn't even want to say that really loud because I realized that could be held against me in so many different ways.
And yet you went on with it.
I was like, it's small, guys.
It's not the size, it's what you do with it.
What the fuck?
Wait. Wait for it.
Did you see that, Jared, when I played it?
Yeah. Oh, dude, as soon as he came up, before he said anything, I was the first one to comment in the live chat.
Before you play it, let me give context so that anybody that hasn't seen it, why I chose this video or why I had this video made. The lady I debunked said that time zones prove her theory that Jesus was born in Great Britain. So I was like,
what?
Yes. So I was like, okay,
that's a lot.
How do you answer that most properly? And I remember on PewDiePie, I saw this thing about this guy on Fiverr who will dress up like Jesus and say anything. So I gave him $10.
Oh, my first intro to him was God, this was probably like 6-7 months ago, or maybe even longer, where someone on the GDC commissioned him to come on screen the way he does on yours and say, Ronnie, you are bitch made. And for those who don't know, Rocket Ronnie is a member of the Clown Car Posse. Total fucking idiot. All right, so are you ready?
Yes.
What the fuck? I wasn't born in Great Britain. Everyone knows I was born in America. Anna, you're a fucking idiot.
Best $10 investment ever.
Best $10 I've ever spent in my entire life. People love that shit on my videos. Or on my video, on the one I just posted. I'm gonna do it more in the future whenever I do my creationist stuff, or when anybody makes one of those dumbass claims. I figure, $10, no big deal.
How the hell does he end up having that business?
It's a great business model.
It is. I'm not denying that. I just want to know how the fuck he came up with it. What series of event led to him creating that?
I don't know, but the other day, me and my son were looking at his channel, and he was like, "Hey, he's live right now." And so we pulled it up, and it was it actually said he was live, but I guess we caught it just as the live stream ended. But it was so it started from the beginning, and he's like, "Hey, it's him playing PUBG," and he opens up, he's like, "Hey guys, it's your Lord and Savior Jesus Christ. Gonna play a little PUBG today." And I'm like, "Oh, I love this guy."
I bet you a paycheck that I know how he actually got started. When he did something similar on PUBG, somebody told him, "Hey, I give you $10 if you fuck off." And then he thought, "Hey, if I can make somebody pay me to fuck off, then maybe I can make money from this."
But you can send him a 50-word script and $10, and in 3 days you'll have your product back. That's fucking money well invested.
Neat. Okay, if there's nothing else to,
I think that's a perfect note to end on.
Yeah, I was about to say,
Skeptic, your water ball isn't downloading. Oh wait, now it is. Now it is.
Oh, hey, hold on. Give him a second. See if he can play this animation real quick.
Yeah, that's a fair point.
That I modeled it so that it's all are rigid bodies and there's no physics. There's no gravitational physics pulling down. Only gravitational physics pulling towards the center of the ball.
Let me see what I got here. It's like it starts downloading, then it stops. Come on, you fucker.
Hey, Rumpus, you could run this animation as well if you had finally enabled hyperthreading.
I will. I'm feeling better now, so I will do that. Oh dear.
Damn, man, I gotta get on these calls. I gotta get my work day started.
Work is for the week.
Well, I own my own business and I have today off. So I was like, I'm just going to take the whole day off and not take any appointments. But now I kind of want to make that money. So I'm going to take appointments for tonight. I just have to set the shop up.
It's like it doesn't want to finish, man.
Finish downloading?
So what you're saying it's some kind of like
here we go.
Downloading?
Oh, now it finally did. Now it finally did. All right, so go get that.
It seems skeptic you're getting compliments on your voice in the chat.
Oh, what about my voice?
He's
he went deeper with it.
Hey, how y'all doing?
How y'all doing?
Hello.
Oh man, I went on non-sec a couple of weeks ago, and I don't know what happened, but something in the everything sounded good on our end when I was talking to the guy, but on the listener end, it sounded like my voice was stretched out and like super low tone, and like at the end of every one of my arguments would end because the next person would start talking. It wouldn't like finish my whole sentence out. You know, it was like it was clipping and then restarting, or that's what it was. It wasn't that he was starting. It was like it was buffering. It was buffering and it was clipping and starting the buffer over again.
There was a bug in the software that they were using. I can't fucking remember the name, which hit me as well when I had to hang out with Shinobi. We could barely hear each other, and the webcam footage from either side would be severely lagged by a matter of minutes. When it came to screen sharing or webcam sharing in this case, because I had to use the virtual webcam to share my desktop. Maybe that hit you as well.
Is it opening, Sly?
Trying to figure out where the hell it went. It's not my normal downloads folder.
The folder name should be Waterball.
Yeah. I know how to get it. Hold on.
In the meantime, let me share the thumbnail for this hangout.
Yes, you need to do that because that was classic.
YouTube, thumbnail experiments, density. Oh wait, I need the censored version.
No, you don't.
So. There we go.
I love how you blacked out everything except the tip.
That's only the tip for Riley.
He looks so hungry in that picture.
He looks like he looks like you just ran into him and he's gonna do some things to you.
No, he looks like he's contemplating if he's traveled far enough away from the city to get away with doing whatever he wants to do to that thing and not getting caught.
It would scare you to know that it's handed to him by his girlfriend.
Yes.
Oh.
The scary part of that is the fact that he has a girlfriend.
Yeah, I was going to say the same thing, Michael. That is very odd. She would. How could you put up with someone who's an idiot, suffers from Dunning-Kruger, and seems to be
I didn't hear
basically a compulsive liar? I mean,
I mean, Riley obviously isn't the worst example. We all know who we're talking about here.
Yeah, Rumpus.
I think we were talking about examples of flat earthers, actually, Micro. So I'm making my comment on that one.
All right. Well, this seems to have downloaded somewhere, and I can't fucking find it.
Well,
it didn't even give me the option.
Well, you have the link, so if it didn't properly download, you can download it. And if you ever want to put that on like a live stream and just show it, that'd be fucking awesome. Because I can't, until I upgrade my computer, I don't know if I need to add another 16 gigs of RAM or if I need to upgrade my video card to run it, or both. But
well, I suggest just checking in the task manager which part of the system is currently used the most.
I didn't even think of that. Yeah, I'll go do that.
Do you have Windows 10?
Yes.
The current version shows you a RAM, CPU, and GPU utilization.
Oh, here. What? Let me do that. Why? Since you have me on right now, what do I? Is it just Task Manager or what?
Afterwards, I don't think the viewers really need to see this.
No, I'm not. You don't have to share me. You can just talk me through it, and I'm gonna run it.
Okay, so you go to Task Manager.
You also don't need to see that.
You go to the Task Manager, and then you go to Perform. Well, obviously, my Task Manager is in German, so I guess the English tab for it is Performance.
Yes, it is.
Then you have CPU, RAM, and all the way on the bottom you have GPU.
Let me see.
Yeah, you should have CPU, memory, disk, Ethernet.
Different disks. In my case,
I see my GPU right here. Okay, so let me run it and see what's slowing down then, since I have all this open.
For the people interested, my computer is currently running a Intel Core i7-3770K, 16 gigabytes of RAM, and a GeForce GTX 970. Soon to be upgraded.
Oh, no.
See, I think
how we've started talking about this, you is never going to stop.
And also, I can use my GPU all the way because I have a 144 Hz display, which means that the monitor is not the bottleneck of the system.
You don't understand how often have to listen to this.
That was interesting.
Oh, sorry.
Anyways,
well, it's loading. Mine's still loading up, so it's about 70% loaded on the animation. Man, if it would work, man, this is a badass animation. I'd love to show it. I can't. I made it for a future video when they say, "Show me water sticking to a ball," and I'm like, yeah, "Okay, here."
I always love answering.
They clearly haven't watched swimming pool porn.
What?
I love telling them to please cite to me where any scientist has ever said that water sticks to a ball.
Right. Okay, so I'm at 50% on my CPU and 28%. Oh, wait, hold on. Now it's loading up. Let me push play. Now let me go to the task manager. Okay. Oh my God, is it fucking working? Don't tell me just running task manager makes it fucking work. No, at some point it's gonna pause here in a second when all the 5,000 drops of water start separating from each other. Okay, now I'm at it. So it's not my video card. Oh, my memory is at 60%.
Well,
that's
do we have
still harmless? What does your CPU say?
Yeah. Oh no, it's my memory. I'm at 100% now.
Okay, then
so it's a RAM thing.
By upgrading the memory, yeah.
Yeah. Okay. Well, look at that, guys.
Alternatively, you could. Do you have an SSD?
Hard drive.
SSD, solid state drive.
Yeah. I don't know. I don't have one in this computer.
Okay, because if you had an SSD, new SSDs are actually fast enough so that the swap file, if you increased its size, might be enough to replace some of the RAM requirements.
Can I not do that with my regular hard drive through virtual memory?
That's way too slow.
It's way too slow, yeah.
Okay.
And not only the bandwidth, also the lag between. Well,
let me. I don't know. Let me see.
Well, I figured out what happened.
It takes to read and write too long compared to the RAM.
When you hit download on it, it what do you call it? It zips it first, obviously at Google, and then when it goes to drop that little pop up that comes up about that, it asks you if you want to leave the site, and I said obviously no, and so it never actually downloaded it, and it was, fucking stupid shit here.
Did you end up being able to get it, or do you have to re-download
it just finished. Hold on a second here. It had to rezip it, so.
I was going to use a model of the Earth, but the Earth already had water on it, so it wouldn't look right with it going there. But it would look like what would happen if we passed through like an ocean, or like a universal or a solar system size ocean.
All right, so hold on a second. Let's see what I got.
Which in itself, wouldn't that collapse if there was a ocean that was the size of a solar system? Wouldn't it collapse down to like a water ball?
If there was a water drop the size of a solar system, it would collapse into a black hole.
No. That's not dense enough.
It's not about the density. It's about their. It's about the middle. Like, I mean, the middle of that ball would stop being water pretty quickly.
Oh yeah, for sure. I'm not
like you would essentially create
the chemistry aspects of it, of turning it into different forms.
Like you would be creating like a very, very weird, like very
a metallic water.
Now, so am I going for player or waterball.exe?
Waterball.exe.
Okay, Sly, I'm gonna screen share you.
Wait, hold on. I'm on the wrong screen. Shit. That again.
Well, that's good, because that symmetry program is so badass, and it was frustrating me that some of my programs, I was trying to model the Coriolis effect in it, and it was running so slow, and I was like, oh man, this is killing me.
Well, this thing seems to have issues anyway. Hold on.
When you click it, it should open up into a pink screen, and it's a loading screen.
Yeah, I'm seeing that, but unfortunately it opened twice, so hold on a second.
Oh.
What program is this with?
Symmetry. Or Symmetry. I don't know how they say it, but they go live on YouTube all the time, and they're doing like live shows where they show different animations and how to build different animations.
All right, I gotta make this so I can actually show it. Hold on. There's that. There's that. So I'm actually gonna have to share the other screen because it doesn't let me choose which screen I want to go to. Say water ball. So present to everyone. Really, I'm presenting. I'm not even showing anything. This share.
Yep, we can see something.
Okay.
I see something that looks like it's from French.
Yeah, it's a butterfly being loaded.
Okay, it looks like it's loading. Yeah.
Those those bars are loading bars.
So is this like a butterfly effect reference, or?
What you talking about, man? That's a bat.
Go fuck yourself.
I don't even know how to respond to you, Micro. Yeah, I'm prepared to pay Jesus $10 more to say something about it.
Like, it's a physics program. Obviously, small changes in the initial conditions are gonna change the outcome dramatically. In other words, it makes sense that it would be a butterfly effect reference.
You're right. Because if I was to take one water droplet to the other side, it would completely change the animation, like the way the water sits on the ball.
Not that part, but obviously, like this, the program can do more than just like your thing.
You know, I gotta fuck with you, Micro.
No, you don't. You have a choice to not. You just choose to do it a lot.
You're my favorite Russian out there, man.
Hey, Skeptic, just remember, after this video renders and it comes up on Geo's channel, watch it back every time Micro's talking with closed captions.
Yes, it's fucking hilarious.
I bet.
It is. Just get a beer and just try and read it.
I'm still waiting for a German flat earther to show up so I could host the hangout in German.
Okay, so I'm hitting play.
Doch.
Oh, it's not going pretty.
Yeah, you're running into the same problems I'm running into.
Here it comes.
If I reduce the number of water droplets, it runs more smoothly, but then it doesn't smoothly conform to the surface. Come on, hit. You're going to make it.
It's like watching the worst stop motion ever.
Yeah,
this
right.
is approximately 1 frame every 15 seconds.
No, these are jumping.
Imagine trying to play a game.
Okay, Sly don't have a gaming computer, all right? So
I do, and it still runs like this on my computer.
What CPU do you have?
Me?
No.
I don't remember the specs on it.
You
but
can
it's,
take a look at the task manager and just give me the number, and I pretty much instantly know what type of machine that is. I mean, I could tell that Rumpus didn't have hyperthreading activated just from the screenshot.
Wow, this is cool. I can see my mouse in the Hangout window, but I can't see it on my screen.
What?
That is so weird.
That's so awesome.
We have the technology.
I'm moving my mouse around my main
That
screen.
is fucking weird.
That's how much it's eating his fucking memory right now.
Yeah, no, but it's weird that the mouse location is being transmitted accurately through the Hangouts.
Through the Hangout, but not on my damn screen.
Like, you would think it would be the opposite way.
So, ladies and gentlemen, this is why rendering computers are so fucking expensive.
Let's talk about Himawari 8 here, right? Now, how can Himawari 8 possibly put out the pictures it puts out with the rendering that it needs at the resolution that it is when we're struggling right here with a fucking fairly basic physics animation that hardly takes anything into account?
Because they have $19 billion a year.
And exactly.
They spent them all on RAM. Just RAM, all
Oh
RAM.
my god, I need to get out of this program.
I feel you, man. I get the same thing happens to me all the time.
See, I just did this in a matter of 5 seconds and showed it quite prettily in
go to performance. Go to performance. I want to see what
Sly, please. It was a very pretty 5 frames.
Yeah, run over to performance real quick. Oh, and it's already gone off, right? You've already turned it off.
2600K, that's 1 generation older than my machine, pretty much everything. What GPU do you have?
Mine says i7
NVIDIA GeForce GTX something.
Your GPU, can you scroll down a little bit?
Oh, why, you want to laugh?
No.
I have a 570.
570, so that's 3 generations older than mine. Shouldn't make that much of a difference in terms of performance.
And 1 older than mine.
Okay, so I have a i7 7700, and it's my GPU is a GT. Oh, damn! I got GTX 1070, and it does that.
Your machine is currently the best that we have here.
Oh.
Because I pretty much know Micro specs, I know Jared's specs, I know Rumpus specs. Sean, no. Hillel, no. But I just assume
you guys need to quit being bums and get a job and buy a better computer.
I have a job. I spend my money on other things besides a better computer.
I also have a job. And
yeah, you saw where my money's going.
Y'all are basically flat earthers to me.
Fuck you too.
Wait. Are you saying you don't enjoy seeing my new toy?
No, I do.
That just sounded wrong.
I think that Riley once said something very similar.
No, but I'm gonna.
Look
I'm
how
about to nerd
fluid
out
this
on
is
that.
rolling.
Yeah,
y'all can't even see it through the Hangout.
And you can still see your mouse too, your pointer.
Yeah, no. I mean, it's running extremely fluid on my screen. It's just the Hangout resolution. But let's see, material. Move this up here. Then turn off that bloosh. It's amazing how fluid this works here.
Have you modeled tides on it yet?
Nah, had no need to.
I love how the little droplets deform like.
Can you do that real quick? Can you put a smaller ball up in the top right corner and give it a 1/6 attraction and see what? Well, I guess you would need to give it less than that because it's a lot closer. But
let me turn gravity off. Let me turn that off. Then I'll take this. Oops. I took the anchor off and it got distracted. All right, so let's see here. We'll hit pause so it doesn't attract this thing over. And we'll put a little ball way out here.
Yeah, that's good right there.
And
an anchor.
Anchor.
God, I'm about to go fucking play with this. I might just not take appointments tonight.
How many newtons squared per newton meters squared per kilogram is gravity?
What is it on Earth?
We just have to simulate. Like you don't have to get it correct.
Okay, so hold on a second here. I just loosened it up a little bit. That's all. Because I had that thing turned like way up. Okay, so now. Am I on the material for this one now?
No, you're still on the purple.
I'm still on the other one for some reason. Okay, material. Oh yeah, okay, it's all the way down. So, and it is playing. Yes, okay, good. If I turn a little bit of attraction on, I think I'm just too far away.
Yeah, you may have to bring them closer.
All right. No, I just don't feel like I'm messing with it at all. Or I just have, or I have this one up too high.
I guess somebody in the side chat is actually making a good point. It would be awesome if you could make the ball with the water on its spin.
Yeah, but it's not 3D, unfortunately.
That doesn't matter.
That's something I could do once I get the RAM. I can make that ball that in the other one rotate.
All right, hold on a second. Okay, so I just need a little bit of attraction on there. And you can see it's already doing it.
Yeah, but it's not doing it like it's supposed to.
What are you talking about?
Supposed to have a bulge on both sides.
Yeah.
Well, that's because these things aren't in motion.
That shouldn't matter.
You have to make the quote moon orbit around the other one.
Right, because the what do you call it? The what was that name of that point? That's like right about here.
That's the Berry center of the system.
The Berry point and all this.
The Berry center.
Yeah, and
that's where all the berries live.
And that's what would make the bulge on the other side. So right now, just by pure gravitational attraction, it's only going to pull up on one side. Now this is pulling up pretty extreme just to make it visible.
Mm.
So I have the gravity turned up like a lot higher. But if I were to go to, let's say, 0.1, and then this right here to 0.1. Now, if I were to let it settle, there would be a small bulge on this side, but it's not going to be very high. But I could probably get it to pull over. Yeah, it looks like it wants to. Yep, it's going.
Shit.
Look at that. That's
going.
Look at the sun going into the fucking neutron star.
Yep.
They do move in herds.
That impact is gonna be brutal.
Yeah, right. Bam! One particle would create so much energy.
Look at the acceleration at the end. That's just crazy.
You like Anthony that much?
But obviously, it seems not to be enough to pull everything off, is it?
Well, because there's still a little bit of gravity over here. I slow the gravity down over there.
We have one.
There it goes.
Oh, wait. Now that everything's moving, that means that the bigger body is inside the smaller body's Roche limit, if I see that correctly. Because the gravity on the surface of the bigger body will actually pull something off the surface of that body.
Mm-hmm. No. Whoa, now everything's starting to like break off and explode.
Did you enable friction? Yeah, you did.
Wait, is Is the water also attracted to each other? Like if you just like had a bunch of water and placed it, would it then attract into a ball of water?
What do you mean?
Yes, that's what I was saying earlier.
Like
once there's enough mass, it should condense into a planet of water molecules.
No, but I'm asking if the water in the program, like, just also attracts each other.
Oh yeah. Do they don't have any gravitational attraction?
I don't think the liquid is designed to have gravity. Hold on a second. Water option.
Hey, Geo or Micro, in my animation, all those water droplets have gravitational.
Well, yeah,
attraction.
that's why it's there.
Boom.
That's why it's getting so complicated, because good calculating everything like a few times before each rendered frame.
Yeah,
because obviously you want to calculate it more than you have frames, because otherwise the accuracy will go down.
But yours crashes computers.
You realize that I do have access to a computer cluster, right?
You do? Yeah. Go make me a video of my animation working and send it to me because you love me.
Oh man, Professor would probably kill me.
Yeah.
That shit was cool. And it is pulling towards the center of mass.
Yeah.
Which would actually be about here.
Yep.
Does it create the center of mass automatically, or can you set it?
Center of mass is going to be the center of mass.
Okay, so Sly, can you?
But you could have different parts of the object be different densities.
Okay,
well, yeah,
Sly.
you can't do that on here. What?
Yeah.
I'd like to ask you, can you model out the acceleration of a car going forward? So let's say we model it with gravitational attraction downward towards the bottom of the screen.
I need this program. I need this
And
program right
then
now. It's
model
free.
a second force in the perpendicular to the gravitational force, and then put in.
That's going to take a while.
What the fuck? It's only 41 megabytes large. I already downloaded it.
Oh, I know. I'm about to. I don't know. Chicks, everything. Everybody's gonna have to stop talking to me so I can fucking play with this.
Look, this is what happens when you have the sun outside of a reflecting dome. Yes, you can do light in this thing as well.
That's fucking badass.
Yep. And then
wait, hold on. That's even fucking cooler.
Can you change the density?
Why did you start out with that?
Can you change the density of the dome? Like the density of the glass to change the refraction.
The density.
Sure.
The density.
Density. Well, no, density wouldn't be the thing, but the refractive index.
Yeah, refractive index would change. Exactly. God damn it. Oh my god, man. I'm so happy right now.
Suddenly I hear dubstep.
Yeah.
I mean, I'm sorry. This is geek crack right here, man.
God, it's just like Stellarium and Universal Sandbox and all those.
What I did was I just put a whole shitload of these are laser beams, and I just put a whole shitload of laser beams. So they made this.
I love that they actually have the little like don't look at it icons on them. That's cute.
And by the way, like I said, the Hangout resolution here is crap. This is all moving very smoothly across my screen.
Yeah, I can actually render it or let this shit run at 144 FPS. Super smooth. So let's see.
Wow, you just upgraded my video, Sly. I appreciate it, man. I always like to put in like little graphics and shit as much as I can, but I just the only ones that I can really get that are good are the Stellarium ones and the Universal Sandbox, because the Symmetry ones just don't allow me to run it on my computer and get a good screen cap of it or a good video file of it. That's what I like about Universal Sandbox. You can create a video file of what you're watching. So you can create the animation, then you can start the video, or you can start the recording process and then click play on the animation, and you record the animation and play back for everybody else.
Yeah, this is that one that I was
Oh yeah, I recognize this.
Yeah, from that one video I did. I don't remember which controls I used though. There it is. And I was showing this is about cloud underlighting.
Oh yeah.
And that's these are the parallel rays of light from the sun. And this is a cloud and stuff like that, and why it is that it lights up behind it underlights the clouds behind you first before it even underlights the ones that are closest to the sun.
This proves nothing.
It's CGI.
Yeah, that's all you've proven there is that we depend on CGI.
I think one of the only complaints I ever really got on this was from oh God, who was it? I don't remember anymore. But he had said that I was showing I somehow stopped the atmosphere, even though I told everybody in that video that was a cloud. You know, it was just funny as hell. No, like I said, you know, folks said that you don't model this stuff out. Well, guess what? I model it out, and I go with what works.
Oh yeah, because we can actually take that model. We could find a place on the planet where this is actually occurring, and we could use that model to base our predictions on what's going to happen. And sure enough, we look back there, and there's light behind us on the clouds behind us.
Sometimes I get bored, and I make little robots and cranes and stuff just to fuck with shit.
That looks like Micro, kind of.
Because
you can actually fucking blind.
Because you can actually set controls. Micro. You could put motors in here and stuff like that, and you can set controls to them and shit.
Oh, so you can actually make little games.
I mean, everything's in 2D, mind you, but you know it still does it.
Fuck it, we need to make a game that we play that's hard.
Well, I mean, if we're gonna make a game, there's better software than this.
Yeah, but this is fun.
Yeah, I was about to say we did it. We can do it in this very simplistic fashion and have fun with it.
Well, remember that old game called Lunar Lander?
No.
Yeah.
Some people do, where you're basically trying to land the
yeah, I'm familiar.
And basically you're just thrusting and stuff like that. And that's I've done that a couple of times on this. It's kind of fun.
I've played another game that's about thrusting.
Yeah, but you need your credit card for that one.
Yeah, fuck you.
And a sock.
And a sock, right? Well, gents, it's getting to be 11 o'clock here, Gil.
Yeah.
Yeah, I know. For me too, obviously. So we're gonna end it right here. Okay.
Hey, I had a really good time, Gio. This show was fun, man.
I don't really have anything to do tomorrow apart from continuing to write my thesis. So let's do.
Oh, nothing. So nothing major.
Nothing at all.
Yeah, well, so let's do the good old rhetoric way. Start from the left, from my side, obviously. So Jared, say what you have to say and get out. Jared.
Spoken like a true gentleman.
He's out playing with his bike.
I'll give him a second chance. But before that, Hillel, you would be next.
Oh, thanks for having me. It was a lot of fun. Anthony's wrong about everything as usual.
Yeah. Thanks for joining. So, Micro.
No.
Hi, Micro. Slide.
Just because I can, man. Just because I can.
Okay, Sean.
Well, we haven't hit this point yet, but statistics say that eventually, if you spot enough bullshit, at least once you'll be right about something.
Team Skeptic.
If you haven't watched my video today, watch my video. Jesus makes an appearance.
Okay, Rumpus. Rumpus. I can't hear you. You're muted. Okay. No Rumpus. Let's try Jared again. Jared, are you still here? Okay, this is awkward. Since both people actually became mute for whatever reason, I'm just gonna end it here. First of all, thanks for watching, everybody. Second of all, a little announcement. I will have a hangout with a Flat Earther on Thursday. It will streamed both here and on his channel. So take your pick, I guess. The Flat Earther is Shinobi333. You've probably seen the announcement on my channel page, so go check that out later. Otherwise, I guess this hangout will be the last for this year because I'm heading out for vacation over Christmas and then approximately to New Year's Eve, and then maybe I'm back. I don't know. I can't tell yet. We will see. Again, thanks for watching and see you next time.